para colocar aqui, esse é para o professor tomar chá. Eu trouxe meu copo, minha xícara da coluna. Esse aqui, William, é necessário essa ligação aqui?
Acho que não.
Acho que não.
Deixa eu ver.
Precisa. Então tirei.
Precisa.
Precisa. Fez barulho também, eu ouvi.
Precisa.
Tem um Benjamin, não? De repente um Benjamin.
Vamos ver um Benjamin.
Se tiver um Benjamin. Eu também ouvi.
Se tiver um Benjamin, eu tiro daí e boto aqui. O que tá. Não vai saber o que eu falo. Good morning, professor.
Bom dia. Bom dia.
Tá, obrigado. Eu trouxe ele, né?
Right.
Eu botei duas vagas. Onde você pôr o banco? Comigo, sai daqui. William, já conheceu o professor?
Nice to meet you, Professor.
This is William.
William.
He's responsible for the technology here, for the transmission. Fala onde é que você faz mestrado.
Also doing my master's course. I'm currently supervisor of Professor Diversity and Inclusion.
And after Professor Norman, William is the most important person here today.
Probably the most.
Here's the calendar of the museum. It's a world of especially children.
Thank you very much.
First of all, we wait to
be careful. That's very fresh.
Passa a boca.
That's good.
Do you need a presenter slides?
No. I'm not going to say this. I'm going to move. So this is laser.
Yeah, laser, no. Here. Laser, here.
Okay.
I have a laser that's green and that's big. If you want a bigger one, I have this one. It's, your laser is fine, it's tiny.
Oh, it's here.
Yeah.
Is this the right one? No.
Já vou ter que ficar ali.
Ok.
Ah, mas ele não vai aparecer ali, porque tem um programa que eu precisava instalar, ele vai aparecer uma célula, fala pra ele.
You will only see an arrow in the screen.
Oh, okay.
Eu nasci para ser mais ou menos. Eu nasci para ser nada. William, eu vou precisar dessa tomada.
Meu Deus do céu, olha assim, né? É você, dona Michelle. Ele é aluno de mestrado da Helena. É, do programa de inclusão.
Sim. Consegui uma tomada. Conseguiu? Eu vou liberar essa para vocês.
Tá melhor que o copo da tarde, o copo do Noel.
Eu falei que ia trazer biscoito, eu não fui na padaria.
Já tá com o Marcelo aí. Já tá com o Marcelo aí. Não, você então, só ficar comigo. Vem pegar a mochila do carro.
Talvez se melhor dessa tirada aí, só gastar, não vai espaço, não. Tipo aquele vidro lá atrás sozinho.
Eu vou tirar.
É. Vou tirar. As xícaras também, eu tô esperando.
Só começar a partir dali. Tira, meu chefe. Pode colocar lá no carro. A verde que é de café.
Mas não é o que ajuda aí?
Oi, eu preciso que alguém pegue minha mochila lá dentro do carro, na parte da frente.
E ali naquela caixa cinza tem a loção de açúcar maior. É, desculpa, né?
My father's name too.
Copo grande porque a verde vai trazer suco.
Boa. Quer?
Depois de
I want to check this.
Pode tirar as varinhas de tirar e botar dentro dela. Vamos mexer aqui.
The same thing we are seeing here, the people we see all that issue.
That is it. This is right? No, this is.
Devices.
Você toma chá?
Perfectly connected to this system. Maybe you cannot see the Professor Alessandra, how this week of Professor Alessandra was telling the first movement here, together with Professor Helena, so she will see the schema, and we will see right here, and the people will see the next one. Just the first movement. So that's why the meet was open.
Eu tenho um adaptadorzinho dentro da mochila do casamento.
And just switching the
Dentro do meu carro.
okay, sorry.
Tá acho que não. Não sei se cabe.
It's a, yeah. Prepare your neck. but you also can see this screen too.
Yeah, that means I have to sit there.
Just turn the computer when you there.
Oh, I see. When after highlight is finished, you turn
Yeah,
it.
we turn.
You turn it.
Yeah, okay. Okay. So, we wait for Professor Rebecca. No problem.
Good stuff.
You could fix it. Maybe mistake, but I don't connect because I can put in other computers.
Vocês pegaram? Pegaram.
You want a chair here?
No, stand.
Okay.
No. I need a cup.
Marcelo na vida. Quem tem Marcelo na vida tem um tesouro aqui fora.
Rola comigo, mas também. Volta de
Eu sei
frente.
disso.
Já pegou Maria. Será que ele vai falar?
I will record from this web. So we need to know where I will stand
Então, peraí.
when you talk. You will be here. Just this camera. So I can put it here. So you will be
I can
here.
be around it.
Yeah. Okay.
I can't go with it.
Yeah. Good. It's the computer that do the video editing. So I only use free software and open code software to do the work. And this YouTube channel is where we.
So what is happening? I'm giving the lecture, then we're having a break, and then Alexandra's going to talk.
Yeah.
So,
And after that, you will have two videos. One is very big video with all the presents, and one video with maybe 20 minutes interview. You will be here. And you can see and our mitigation.
This is your job.
This is my job.
You're not doing a degree as well. Are you studying as well?
So you're doing a master's degree to the same university.
In what is your master's?
Diversity and inclusion.
Oh.
It's includes science and education. The subjects. Science and
So you know it, don't you?
yeah. And we are studying the impact from videos in the inclusion science education. Using videos to teach about oral health from people with autism.
A gente vai estar aqui essa lista para entrega do certificado a partir da manhã e na parte da tarde, tá? E os alunos do melhor 2022 e 2024, a listinha aqui, tá? Aí vai ser o intervalo que a gente der no final do
I have
certificado.
a pointer for blind people, like we can. I have a visual deficiency for
Assinar por causa
So
do...
you have to pass this point with this one. So you have to help both.
My brain doesn't move.
Yeah, it does.
Ele falou assim, devido a alguns contratempos, está sendo adicionado assim, só vai
So on Friday.
I talked to the Felício,
sim, são duas assinaturas. Só para a liberação do certificado.
Já pode entrar no Meet para chamar a Helena?
Já pode.
Reativa esse
Ela está falando aqui que ela está tentando entrar, ó.
Isso, não é a presença do certificado.
Abrir aqui a reunião, qualquer um pode entrar. Pra gente.
Já está?
Aqui ela não vai ver.
Hi. Can't you hear us? Yeah.
Bom dia, professora Helena. Bom dia. assistindo só. I check with the microphone and it's here. Just let's do it.
Alô? Olá? Oi?
He needed an extra hand.
Oh, yeah. It's
If
true.
you want, we can pass the slide for you. You can see. Next one.
We just do that.
Yeah.
And I could just use the microphone.
Yeah.
That's really good.
You can leave the thing with William or with me or with
Alessandra, precisa de passador de slide?
Não, não tem.
Would you?
Yeah,
Because
Não, é porque ele vai fazer com um microfone, um passador, um pointer. Você vai passar? Então, tá.
Remove those. Oh, it's good.
try not to fall over.
inglês, a gente traduz para vocês, os professores ajudam na tradução. A gente vai ter essa sessão agora de manhã da palestra, a gente pode fazer um breve perguntas e respostas, porque a nossa ideia é pergunta e resposta na parte da tarde, para a gente debater mais, fazer vocês falarem também, tirarem dúvidas com ele diretamente, e a gente à tarde vai ter no auditório, talvez com mais uma palestrinha de 1 hora. A gente vai ver como que vai funcionar, ok? Vamos sentar aqui. 10h30, 10h40 mais ou menos, a gente vai parar aqui, a gente toma um cafezinho e a gente vai fazer uma gravação lá no estúdio, uma entrevista do canal do YouTube aqui da pós-graduação. Então vocês vão estar liberados depois desse horário, 10h30, 10h40, e retornando às 14 horas aqui no auditório. Tá bom? Well, now it's time for English. Good morning, everyone. We're starting now our first international meeting of the postgraduation program in dentistry from Federal Fluminense University. We are pleased to have the students here. Most of all, we're honored to have you here, Professor Norman. Professor Norman, we met by Professor Helena Castro, who was the coordinator of research at the university. She's a professor at Biology Institute, and we met because of the project of internationalization of our course. We want to exchange opportunities and experiences, and we want to bring foreign students to Brazil, and we want you to have the opportunity to go abroad as well, and to go to congresses, and to present your research, your work, and to understand the importance of publication, of scientific publication. So we met in the rectory, and we made these plans to come here to talk to the students. I have plans for Professor Norman to work with us at the English discipline in our post-graduation program with seminars. And Professor Norman, he's an emeritus professor of Swansea University. It's in the United Kingdom. He's been doing research in insect immunology, and he has already been a partner in Fiocruz. He has been a visiting researcher in Fiocruz from I'm not sure if I could say the dates right, but from 1991 to 1994, and then he came back to Federal Fluminense University as a visiting professor from 2012 to 2016, and then from 2019 to 2023, he's been contributing with post-graduation programs. He's been working, helping students with study methodology and with English review of papers, and with classes and seminars as well. So we are very honored to have you here. It's a pleasure, and I'm sure you all have a good time and learn a lot from Professor Norman. So I'd like to ask Professor Helena if she can come in and say some words for us. Hi, Elena.
Hi, can you hear me?
Yeah, very nice.
Perfect.
Yeah?
Yeah.
So, good morning, everyone. Thank you for inviting me to participate of this important moment here. It's something about internationalization that has been required the post-graduation course to invest into. And the Dr. Norman Ratcliffe is more than a visiting professor. He's a dear friend of me.
Okay. Can I speak with them?
If anyone has any question or something that you don't understand, you can just sign for us and we can stop and translate it. Everyone now I'm going to check. Everyone's okay? Everyone's getting that? Is it difficult to understand?
Okay. To the bom. Desculpe para não falar português. Se eu falar português, ninguém entende. So I won't say any more. Is it better I speak like this or with this?
Just.
It's not working, huh? Hello?
It is.
Which is better, this or me like this? With a microphone. Okay. So I understand that people here have different levels of understanding of English. So this seminar today, I will try and speak fairly slowly, and I will pause frequently, so to make sure that you understand. If there's something that you don't understand and it's very urgent, then please do stop me and we can try and answer your questions. But this afternoon, I think, we also have an opportunity to interact together. So without any stopping now, we'll begin. This is my first slide. Can I make slide, please? As I said, I will speak, and what I'm saying will be in the slides. So, as I said, people will find it difficult, some of you will find it very difficult to understand everything I'm saying. And it's also quite difficult to publish in a foreign language. If I had to actually publish my papers in Portuguese, I would have published nothing at all. And I appreciate your problems. It must be a terrible thing to try and write a scientific article in a foreign language. I would have given up. But hopefully, I will help you with English because most of the most significant journals are actually published in English, unfortunately. So that's Europe and America and Western world and South America. So we have to, in some way, master the ability to write and speak and understand in English. That's it. Next slide, please. Next one, please. So the title of my talk is Some Basic Guidelines for Scientific Publishing. And it's based, these are my views, they're not written down anywhere, and they certainly don't follow any published material, books, etc. I'll give you the basic principles, and next slide. Next slide. Right. If you want to learn English, you could, of course, buy a book writing science research articles in English. And those books will tell you how to write, what to write, and provide clear processes for writing each section. Now those books are not easy to understand. I'll give you an example. Next slide, please. Here's an example of two phrases, which are the first one is from the book, and the second one is my interpretation of the meaning. So the first one, I'll read this. If you understand this, you'll do it very well. The fundamental purpose of a scientific prose is not just the presentation of information and thought, but actual communication. An author might be pleased to have converted all the right data into sentences and paragraphs. It matters only whether a large majority of the reading audience accurately perceives what the author had in mind. Now that was taken from a book on learning English and doing presentations in English. It actually means, this is my interpretation at the bottom, the purpose of writing a scientific paper is the communication of information. The only thing that matters is that the readers understand the author's thought. Now I think that's easier to understand than the first paragraph. The purpose of writing a scientific paper is the communication of information. The only thing that matters is that the readers understand the author's thoughts. So I wouldn't bother to go and buy a book and read it too much. If you attend the scientific English classes in UFF, then you'll probably do much better than buying a book. Next slide, please. The purpose of the talk. Well, I'm not going to tell you about the basic mechanics of English, prepositions and verbs and adjectives, etc. I just want to give you some indicators of how to construct your paper and produce each of the component sections. In other words, introduction, results, discussion, etc. And I also want to give you some ideas for maximising your chances of publication. But this is my view. And other academics probably have other views. Next slide, please. Why should you publish? Why should you bother to publish? Here's some ideas. To communicate your findings to the scientific community. To satisfy your MSc or PhD requirements. To get a job. You have to publish to get a job. And you also have to publish to get the job, because if you don't publish, you lose your job. To get research funding. You can't expect to get a million reais, like somebody in this room, without having published. And to get promotion. You don't want to stay as an assistant professor all your life. You want to try and get promotion, get a better salary, and also get more invitations to do research in different places. And also, the higher posts you have, that it helps you with interacting with other people and getting funding. So there's very many reasons why you should publish. The ideal is to communicate your findings to the scientific community. But if that was all, then we wouldn't survive. We have to have these other things as well. Next slide, please. When should you publish? When should you actually publish? The ideal is when you have significant results. That's the ideal. When you're invited to a congress, or meeting, you may be invited to a congress. That doesn't mean to say that you should go. There's no point in going to a congress if you've got nothing to talk about. I mean, I couldn't be here today talking to you unless I had something significant to talk to you about, hopefully. You can publish if you're invited to write a paper or a review. Now, these invitations used to be quite difficult to obtain, but nowadays, because the increase in number of periodicals, everybody seems to be getting an invitation. But there's another side to that, which I will deal with. It will cost you money if you accept the invitation. When your advisor tells you, well, that's a good thing. If you have an advisor for your MSc or MA and your PhD, then you obviously will talk to your advisor about whether you should publish or not. Next slide, please. When should you not publish? Well, first of all, when you have no significant results. Secondly, when you're applying for a patent. When you have found a new antibiotic, then you don't go and publish straight away, because if you do, the commercial side, the businesses, will copy your finding, and they will bring it to market, and you will receive no money or no recognition. So you don't publish when you've made a finding which you can be patented. You cannot publish when you do not know the literature. Now, you're going to hear me today nagging you about reading, because I know that most students today don't read enough scientific information. You don't just read about your subject, but read around the subject to get an idea of the significance of your work. You don't publish when you are invited to write a complex review. Now, this is something that Ufi and I actually disagree about, because I think most PhD students, when they have their viva, their final interview, have actually to publish a paper or two in the form of a review. Now this is a very difficult thing to do. A good review is a very complex subject. So if you have to write a review, then you need to consult with somebody. And I don't mind helping you. But I mean, if everybody wants me to help them, then I can't. But I can help people because I spend my time writing reviews now, because as I'm retired, I don't have a laboratory. So I use my experience to write reviews on topics which lead a good overview. Next slide, please. Where should you publish? We all want to publish in Science and Nature and PNAS and places like that. In open access journals, in high impact journals, journals relevant to your research area. How can you decide where to publish? This is a big question. Again, you cannot make this decision by yourself. All of you have an advisor, is that right? Anybody doesn't have an advisor? So your advisor, he was used to me. They're paid to help you, okay? Next, please.
Oh, sorry.
Oh, no, the one before that. Yeah. This is nature. I don't know why I've gone on to nature. I've given this lecture before. Nature is an ideal journal to publish in because it has a very high impact factor. What does that mean? It means that it's regarded as being very scientifically significant. Not just scientifically, but very significant by the research community. But this gives you an idea of how difficult it is to publish a paper in Nature. These are the years here. This is the weekly number of papers which are submitted throughout those years. And this is the number that are actually published of those submissions. And you can see that the percentage publish rate is gradually decreasing. So it's 1 in 7, 1 in 7, or 1 in 8. It's probably less than that now. Next slide, please. Next one, please. You can go to other journals which are associated with types of organisations, such as the Royal Entomological Society, the Biochemical Society, Social Sciences Committee. Many of these organisations actually publish periodicals as well. So it's possible to look for those type of journals because they're very significant and they will be very helpful to you. The publication rate, as you can see, the average publication rate for the British biotech, what's that say? British biotech, something is 27, 28%. British microbiology, 28%. European Journal of Nutrition is 20%. One in 5, something like that, which is still quite difficult, but better than trying for Nature and getting frustrated. Next slide, please. I'll tell you more about Nature. Again, Nature is our ideal publishing, but get that out of your mind at the moment. The problem with Nature is it does not employ an editorial board of senior scientists. It has an editorial board composed of people that have degrees, many of them in biology and social sciences, but not necessarily covering the whole gamut of subjects in the area. But the idea is that they have so many of these people on their editorial board that they can cover all the subjects which papers are submitted to. And they believe they have a much better idea of what is going on in the general areas of research than 2 or 3 referees. Because the normal thing to do is you publish it, you submit a paper, and it's sent out to referees, 2 or 3 referees, and they give comment on that paper. And if they're in favour of the paper, it's published. Well, Nature doesn't work like that. They go out to referees, but they have these editorial boards, and they decide if a subject is sexy or not, sexy enough for them to publish. Because they want to be at the forefront of new science and new social sciences and new areas of research. So they try and identify, it's a bit of a bandwagon. Do you know what a bandwagon is? It's when something comes in fashion and everybody wants to do it. A bit like when the Beatles were going and everybody wanted to buy their records and see the Beatles, you know? Everybody wants to be there. It happens in fashion all the time, doesn't it? Well, it's the same with nature. They want to be at the forefront. And so sometimes what happens, they don't identify the new areas of research which are going to be significant in the future. That's the problem. Next slide. Does everybody understand this? Everybody understand that? How many people here, tell me truthfully, put your hands up if you understand that title. Anybody? Right. Well, when you submit to Nature, the usual letter you get back is that your paper does not appeal to enough of the reading public. It doesn't appeal to enough of the reading public. Do you think this paper, as it was published in Nature, do you think that paper appeals to the general scientists? People who understand? Of course it doesn't. This is an explanation which I'm not going to go through. Okay? Next slide, please. Types of journals. Oh, there we have bandwagon journal. I've said this, society-type journals are good ones. Next one, please. This is an article which was published in Nature from one of my ex-postdocs. And this is a much better title. Invertebrate extracellular phagocytic tract show the chromatin as an ancient defense weapon. Now, again, not many people probably understand that, but at least people know what invertebrates are, so we're starting to understand part of it. Invertebrates. Phagocytosis. How many people have heard of phagocytosis? This is the ingestion of foreign particulates, okay? And an ancient defense weapon. So you can imagine there are phrases there which are quite appealing. Better than that other paper, which was incomprehensible. Next slide, please. Right. So, how are you going to select a journal for publication? As I say, society journals, lots of societies have journals. For example, EMBO, European Molecular Biology organisation. It has an impact of 10.33, so that's very high. Anything over 3 is probably 2.5 to 3 is acceptable. The advice on where to publish now has been totally turned upside down by the appearance of different journals almost on a daily basis. I mean, you probably know, Alessandra, you probably get each day requests to publish in this journal and that journal and something other journal, which are open access. If you publish in an open access journals, oh, I have an invitation published in this journal. Oh, fantastic. Oh. Then you're going to bill for $2,000 or $3,000 because that's what they're at. They want to make money. They want to make money. PLOS is included in this, but PLOS, have you heard PLOS journals? Yeah, PLOS journals. I'm a bit thrilled about PLOS journals because the power is in the hands of a very few people on different subjects to make the decision. And they sometimes manipulate, if the paper that's submitted that they have to look at is in their area, they reject it. I'm afraid scientists are human beings and they get jealous and protective. So, but on the other hand, I found PLOS to be quite good because what PLOS has is a waiver policy. So if you're from Brazil and you you submit to PLOS, one of the PLOS journals, you can apply for a waiver of the open access fee. And they're quite understanding. I find them quite understanding. Because unfortunately, UFF doesn't have money for paying open access to help it publish. So remember that open access. PLOS I think if you get a paper in class, I think it's really good because the impact is 3, 4, 5. Really good. Next slide, please. What is the impact factor? I've been on about the impact factor of a journal. Okay, what you don't want to do when you're invited to publish, or you're trying to select your journal, what you don't want to do is pick a journal which has a low impact factor, of 0.5 or 1, less than 2. Okay? You really don't want to go for anything less than, say, 1.5 to 2. That's the minimum. The impact factor is this. The impact factor is the number of citations. And now, what is a citation of a paper? That's when someone else reads it and then cites it in the bibliography. Okay? They say Fred said this, that, and the other in 1953, and it's in the bibliography. That means that work is worth reading and has made an impact. It's not just being published and sat there with nobody taking any notice of it. So the impact factor, and the number of citations, the number of people that have read it and cited it subsequently, a journal receives in a year for articles published over the previous 2 years. In other words, the number of articles published over the previous 2 years. Citations for the previous 2 years. Divided by the number of articles published in that period. Just remember, if you can't remember that, the impact factor is important. Don't publish in a journal which has a very low impact factor. Recently I received an invitation to write a review on the microbiome, the microbes in the intestine. And it's in a paper in a journal called Nature, Cell and Science. Which is the 3 top journals, but it's put the 3 top journals' names together to produce this journal called Nature, Science and whatever. So the bottom line is, only go for these reasonably high impact journals, something 1.5 to 2. If you get higher than that, so much better. In actual fact, the funding bodies, CAPES, for example, which I don't know what that stands for, CAPES, has lists of journals, and it lists those journals which have a decent impact. And it lists the A journals, the A list with the highest impact, and the B list, which are reasonable impact. And they recognise those journals when you're applying for funding. So if you're applying for funding and you've got quite a few papers which are in list A and B, you're more likely to get the funding than if all your papers you've published appear in list C and D. So impact is very important. Doesn't matter what it means. Don't understand what it means. It is important. Next slide, please. Here we are. Elsevier. I don't like Elsevier. I dislike them because I'm retired means that my brain can't be flushed down the toilet, and I cannot apply for funding for open access unless I ask for a waiver. So I'm being quite clever in avoiding paying open access because I'm an old person. I have lots of contacts and they help me. They pay for the open access if they put their names on my paper. So it's an exchange, if you like. But Elsevier, a wolf in sheep's clothing. A wolf in sheep's clothing. I find them difficult. Next slide, please. Elsevier, a Dutch company, we had this conversation with this Dutch, claims to publish 80% of the world's scientific papers, and it reported a 10% increase in its revenue. Unfortunately, that part of the slide disappeared. 2.9 billion pounds, I think. 2.9 billion pound profit last year. that profit is based on using academics, scientists, other academics, because academics referee the papers, and they referee them for nothing. So you can spend hours on a Sunday refereeing a paper for someone you don't know, you don't get paid for it. And then you send the report back to the publisher, and he publishes the paper, gets the open access fee, and keeps it. Doesn't help the scientists at all. And the scientists were pretty stupid. We go on with this system, and in actual fact, one of our savings journals in neurobiology, the whole editorial board recently resigned because they're using and abusing the referees and the academics. It's there. It's everything I've said is there. You want to read that for a moment? Do you want to pause for a moment? Are there any questions? Do you have any questions, please? So we've learned about the impact factor, very important. We've learned about the fact that you can apply for waivers, that's important. And the trouble is, Brazil is not on the list of countries which these journals provide waivers for. God knows why, because they think that you're still in the Lula halcyon days where there was so much money going around. Then Bolsonaro came in and cut the funding. And I don't know what the funding is doing now. Is it increasing with Lula?
No, it's not increasing. No.
So you're still in that situation.
The universities are in a bad situation, yeah.
So if you submit your paper to a journal, you must make an application for a waiver. In other words, I don't want to pay the fee. And you point out to them, although that Brazil is not in their list of countries for which they provide a waiver, the universities cannot afford to pay for open access because of the previous president who cut university funding. I think it was 50% or more for some universities.
I'm not sure about the number.
It was very, very significant. Okay? Next slide, please. Right, here's some help in identifying predatory journals. These are the journals which will prey on you, don't have a high impact, and will try and persuade you to publish and pay their $2,000, $3,000 fee. This will help you to identify predatory journals. First of all, you need to look for a journal which has been published for many years, maybe attached to a society. Because this explosion in journals, has occurred in the last 5 years, 10 years. And many journals, the real good journals, have been publishing for 100 years. Check the editorial board. First of all, see if it has an editorial board. See where they come from. If they're all from Turkey, don't publish in it. If they're all from India, don't publish in it, okay? You want to see an international editorial board, okay? And what I do as well, I look at the editorial board very carefully in my particular area, because they have editors in different areas. And I look at the name of somebody, one of the editorial board members, and I look him up on the web, he or she up on the web. I look at their papers. They're on the editorial board, they should have a good collection of papers. You know? If they don't have any papers, or they don't exist, that's a joke journal, it's a predatory journal. So that's a really good thing. Investigate the editorial board. You know, Turkey and India. If the journals from Turkey or India, also seek from mentors in the lab. You all have mentors, they have got previous publications, and they probably have good journals that they publish in, so they can help you. And as I said, look for journals published by universities, Oxford University, Cambridge University, and societies. And then finally, scan articles. Find out you're interested in the subject of particular subject you're researching on. Find who the experts are in your field. Do a scan of the literature. Find out who are the experts and see where they're publishing, which journals they're publishing. If they have favourite journals and it's got an impact, that's a journal worth thinking about. So there's some advice there. Are there any questions on that?
Yes, I have a question. It's our pleasure to have you here.
Thank you.
Thank you for your shared experience with us. And I would like to know about what do you think about Brazilian journals?
Perhaps you shouldn't ask me, perhaps you should ask Alessandra, because you do have one or two reasonable impact journals in the Brazilian Society.
Some journals. I was going to ask that. I just noted Gabriela works with me in the department. I was going to ask you that because you just said that journals from Turkey and India are suspect. And we wonder if people look at journals from Brazil and say, wow, this is Brazilian research. These are Brazilian universities. We have some journals that are A1, A2, that are really, and it's very hard to publish on these ones because we have a lot of universities, a lot of students, a lot of papers going on, and they don't accept it. They only accept if it's perfect research design and with nice statistics. But we have some ones that are international and are respected. But Brazilian oral research. It's from the Brazilian Society of Research in Dentistry. So Brazilian oral is one of them. But we don't have that much. I don't know in the basic field that Vinicius works with cell biology. You have papers, you have journals that are A1, A2 in Brazil, no. So they're kind of rare. So we end up publishing in B1, B2, B3. Those are the most common from the medical societies. But I don't know, do people abroad look at Brazilian research? How do they look at it, or they don't?
I don't think they look at the Brazilian journals. I published once in Brazilian journals, but it was with Brazilian colleagues. And my Brazilian colleagues have published in English-speaking journals, English published journals most of the time. But I mean, if you're working in a particular area like Brazilian Journal of Oral Research or whatever it was, and that is in A1 in cafes or A2, and you're applying for money from cafes, it's not a bad idea actually, I thought, to publish it there. It's probably a good idea actually.
No, it's important to publish there.
Yes. But I mean, if you then get a joint grant with somebody in France from the European Commission, that work that comes out of that will probably not be published in the Brazilian journal, it'll probably be published in an English published journal, probably, because you want to be recognised internationally.
Yeah,
I mean, it's a great shame. It is a great shame.
You know, the feeling that we have doing research in Brazil is that the societies from Europe or from the United States, they have their societies and they publish the things from their people, and it looks like we're foreigners. We are foreigners, but we're trying to get in, we try to publish, and we have the problem of funding, because we do research here with little money. We don't have that much money to invest in laboratorial things. It's a hard work to get funding and to publish like this scientific research that can be published in a high impact factor, for example. So it's hard for us to get there.
Well, you need, I mean, the bottom line is try and interact with somebody from America or Europe or somewhere.
Looking forward to interact with you, actually.
Yeah, well, so it is a great shame. And what you say is actually right. The worst journal for publishing is PNAS, proceeds of National Academy of Science USA, because you have to publish with a North American fellow of the American Society, whatever it is. You have to persuade somebody from that society to back your paper. And it's a sort of closed shop. And as you say, Nature, if you're from Oxford or Cambridge and you try and publish in Nature, I'm sure it's about 10 times easier. Especially if you've got a FRS, Fellow Royal Society, or you're called Professor John Smith, FRS. Here we are. That's trying to identify predatory journals. Next slide, please. Right, we're actually coming to look at the sections of the paper, the publication. Organisation of articles. So the types of paper. Full-length articles. This is what most people will publish or submit. Full-length papers, original research. Then there are short communications. If you've done some research and found very significant findings, that you want to publish them quickly because there's a lot of competition out there, you'd guarantee, if you had a research idea, someone else in Mongolia has thought of the same thing, or something very similar. So short communications, rapid communication of initial but significant studies. You don't have separate sections, that's just written in one section. The original articles have defined layout. This is what I'm going to tell you about in a moment. Then there's review articles. Not usually with original results, and the organisation is up to you. So most of you should be publishing here. Full-length articles, introduction, materials and methods, results, discussion, etc. Next slide, please. Original full-length articles. Decide on a journal, read the instructions to authors, which will tell you the scope of interest of the journal. You select a journal, you must read what the scope of interest is. Make sure it fits to that journal. How to organise the paper, they will tell you. Any word restrictions, how to formulate the figures and the referencing system, and how to submit online. One of the worst things about submitting papers is the actual submission process. It can be very time-consuming and very frustrating. Do you find that? With submitting articles, difficult sometimes. Now, original research articles are usually divided into summary, introduction, results, discussion, acknowledgements, references, and additional material. That's the layout. Next slide, please. Here we are. My goodness. Just about to see that. Summary. Synthesis of the work. What's happening? Something's happening here. Okay. Synthesis of the work. That's a summary. What is being written and the most significant findings, okay? That's a significance. Sometimes called a resume. Introduction. Now, introduction places the research in context of previous work and justifies the study. The introduction is the most, well, not the most, but is incredibly important because people like to scan through papers. They read the summary and they say, oh, that's interesting. Then they want to know really how significant that research is. So they read the introduction. And the introduction justifies the paper. Justification. It's most important. And we'll come back and talk about that in more detail after. Methods, how the work was carried out, description of any different groups of experimental animals or people. That's easy to write. It's easy to write. I'll tell you why it's so easy in a moment. Then there's the results. The results of the research, tables, figures, and statistics. Discussion. Now you've presented your results, you've put your paper in context of what's been published previously, you've justified the paper, you've produced your results, the figures, the statistics, etc. Now you have to discuss how important those findings are, how important your results are. Relevance to your results in previous knowledge, and how your work advances the field. How your work advances the field, okay? You can cover controversies and future directions as well. Future directions. So each section has its own characteristics, and you have to stick to those sections. You can't include in your results of this discussion. You can't include your discussion in the introduction. You just have to stick to this format. Next slide, please. Now you're coming to write your paper. Oh my God, I can't. A blank piece of paper. What do I do? You know, it can be awful. This is something many people may experience. Have you all had experience of not knowing where to start this piece of blank paper? Yeah. Have you ever heard of subconscious writing? Oh. Never? No. Well, maybe I'll tell you what it is. I'll tell you now. Often I'm writing a paper and wondering maybe about the main subject. I did this recently. I found a topic I was interested in, and I thought, well, how do I organise it? Because it was quite difficult. I was actually looking at other people's papers and basically criticising them. So I had to be very careful. So I needed to have headings. I couldn't say, well, this is rubbish, this is not rubbish. So I was wondering about the main subjects, the heading, and I forgot about it and went to bed. When I'm in bed half asleep, my wife doesn't know this, or the next morning, sometimes things just pop into my mind, and the sections a bit. And I have been known recently to get up and write down a title of the paper. I was thinking, well, what can I call it? And then I thought, oh, no. And it came to me, so I thought, well, I can't go back to sleep now. I have to write this down.
It's fun because I already dreamt about the things I was studying, and
that's subconscious.
When you wake up, it comes to your mind.
Yeah, that's subconscious writing. And there's quite a lot of information on the internet about subconscious writing. Has anyone experienced subconscious writing? Whether it's, even writing a letter to somebody, writing a letter to your boyfriend or your girlfriend, and not knowing exactly what to say, and then something's coming to you, I'll tell you this now. I'll just tell you. I didn't go to bed with the idea of solving the problem. I've given up thinking about it. I'd probably watch a television football match or something like that. It doesn't have to be, oh, I'm going to bed now, so this idea is going to pop into. No, it just pops into your mind. Because it's on your mind because you're trying to write a paper, and it just appears. And then many people find it. Next slide, please. Oh, here we are now. This is my nag point for this talk. Know the literature. There's no point in beginning to write a paper unless you know the literature. No point at all. In fact, when you choose a subject for research, you need to do a full literature research before beginning in the lab or on the computer. You must know. How else will you know your project hasn't been the subject of publication or research before? You can only know by knowing the literature. You've got to know what's been published. And I will give an example how serious neglecting the literature can be. I have an example here, which is cited to my paper I just submitted to my colleagues. Next one, please. I'm talking about arthropod blood cells. Now, this is something you've probably never heard of. Do you know that insects, spiders, crabs all have blood cells? They all have white blood cells like us, same as us. Okay? And there's one particular insect, the fruit fly. You know what the fruit fly is? Drosophila. When you have a bowl of bananas or rotting fruit, those little flies that fly around, they're fruit flies, and they're called Drosophila. And those fruit flies, the genetics of those fruit flies, has been explored backwards, sideways, etc., etc. And what has emerged from this research on fruit flies is the fact that they have innate immunity. They have immunity. Those little devils have immunity. Like us, they have immunity. Now we have immunity. We have two types of immunity. We have innate immunity, which is there all the time, okay? When you have an infection, you immediately get a response. That's innate, normal immunity. But as time goes by, we have a second type of immunity which kicks in. That is acquired immunity. That's the antibody responses, okay? But fruit flies and all invertebrates have innate immunity. And it's almost identical to ours. Now, isn't that extraordinary? Extraordinary. And a friend of mine in Strasbourg, Jules Hoffman, I think I have a slide. Have a look. Come next slide, please. Yeah, there we go. There's all the invertebrates, and they've all got these white blood cells. And I'll show you some white blood cells. Worms, butterflies, crabs, starfish, octopuses. They've all got these innate immunity and these white blood cells. Next slide, please. Yeah. Now, I didn't quite finish what I was saying on Drosophila. That little fruit fly has innate immunity. And my friend, or my colleague, not my friend, I wish he was my friend, Jules Hoffman, he worked on these fruit flies, and he found something called the Toll, T-O-L-L, receptors. And those receptors recognise foreign invaders back here, okay? And he published a paper in Science with a picture of a Drosophila with fungi growing out of it. And he announced the fact they had innate immunity, the same as humans, by means of the toll receptors. And some mammalian immunologists read this paper, and bang, they suddenly realised, because they knew that humans, mammals, vertebrates had toll receptors, but they had no idea what they were doing. They only found out because of Jules Hoffman's work on the fruit flies. And as a result of that, the mammalian people then researched the toll receptors and other types of receptors in immunity in humans. And all sorts of new therapeutic agents have been tested on the basis of their findings in Drosophila. And Drosophila has been used also for looking for new components of our immune system. So the next time you see those fruit flies buzzing around your bananas, just think about that. Or when you're driving on a hot summer's day and all the insects are banging onto your windscreen and killing themselves, and that yellow-green liquid that comes out, that is their blood, and inside there are the white blood cells. Same one, similar white blood cells to us. Now, in order to, the other thing, of course, is that lots of insects are vectors of disease. And we're very interested in finding out how it is that those insects carry those diseases. So when a mosquito takes your blood, it takes up the parasite, Plasmodium. And that parasite doesn't stay in the gut and do nothing. It develops. It goes through stages. And eventually, the mosquito is full of the parasite in the salivary glands, because the parasite goes from the intestine through the blood of the insect, through the salivary glands. And in the salivary glands, there are thousands or even millions of these parasites. So when the mosquito takes a blood meal, you are infected with the saliva containing the parasites. So we've been interested in finding out how it is that the parasite avoids the immune system of the vector and what molecules are involved. So it's quite important. But it's not just mosquitoes. It's things like sandflies and tritonic bugs, all carrying these horrible diseases.
How do you say abril for Chagas disease? The name of the insect, abril.
Tritonic bugs, rodents. So we want to, sorry, so what scientists want to do is they want to take these blood cells from the vectors, take the insect blood cells, and study them in vitro under the microscope by doing sophisticated sequencing techniques, gene knockout, and all these sophisticated molecular techniques, find out the association between, or the interrelationship between the parasite and the insect vector. So to do that, you've got to bleed the insects, you've got to get the blood out of the insects. Now, the Drosophila is quite small, as you know. But even so, next slide, please. This is actually another insect which we use. This is it's called a wax moth. It's like a maggot. You know the maggots, the musky maggots, like that. And what you can do, there's the maggot. You can sterilise the out. This is how you get blood. It's how you get blood out of the insect, right? Rather than the insect getting blood out of us. So there's the larva, Calerium, called wax moth. You clean the outside. You put the insect on ice so it stops breathing. Okay? And then you put a pin or a pinprick or a scalpel, and you make a small cut, and the blood oozes out. You collect the blood, then you collect the blood, and then you have the blood and you can look at it under the microscope. So that's how you basically clean the insect. I'll come back to that in a minute. Next slide, please. And here, this shows you the blood cells. These are all white blood cells in an insect from this wax moth. You can see there's quite a lot of them. You know the cockroaches, what do you call them? Baratas. They contain thousands of millions of these white blood cells. They're resistant to everything. That's why they live in disgusting areas. Well, they live in disgusting areas because they have thousands of these blood cells, millions of these blood cells, and are very resistant to all diseases. So they're worth studying, believe it or not. I work with cockroaches, it's absolutely disgusting. So there's the white blood cells. This is stained with a green stain, and this shows them under the scanning electron microscope. There's the blood cell taken up, ingesting from particles. Next slide, please. So this is the bleeding and what they look like. The problem is, this blood that comes out of the insect, it clots. You know, we cut ourselves, the blood clots. Well, in insects, it clots 10 times, 100 times faster than us. Much faster than us. Next slide, please. This is what, instead of seeing that nice, you go back to 2 slides, reverse. Sorry. One more. This is without clotting. And now go there. You see what happens. Now you can't work with this. It's rubbish. It's a clot. It's the same clot as us. Fibrin molecules, you know? It prevents the loss of blood. Next slide, please. So we have to avoid that. The cells have to be stabilised for experiments. And scientists in the 70s and 80s, that includes me, published protocols on how to stabilise the cells. Okay? And that's published. And it's published in, ever heard of Limulus? Horseshoe cracks? horseshoe crabs are about this big, live on east border of the USA. They contain masses of blood cells. They're very important. Okay, but be careful I don't get sidetracked. Okay? So they have to be stabilised. So we worked on stabilising and also other people. But more recently, people have revisited these cells, these stabilised cells, because now there are molecular techniques to study. When I worked on it, we had a microscope, we had an electron microscope, we had some labelling, but we didn't have these sophisticated molecular techniques. Now scientists have come back and say, oh, God, we can apply these molecular techniques. And these molecular techniques include single-cell RNA sequencing. So they can take individual cells and they can analyse how they function and what they produce, what the genes are doing, and the different conditions, infection and non-infection. Molecular techniques are amazing. And these scientists you see the papers, they're so complex. Gene silencing, advanced molecular techniques. Well, some people will be doing this in UFF. Okay, next slide, please. Unfortunately, these high-power studies thought that insect cells could be treated the same as the mammalian white blood cells. Oh, sorry. Unfortunately, these high-power studies thought that the insect cells could be treated the same as mammalian blood cells. In the literature, it says, oh, insect or arthropod white blood cells are the same as neutrophils. Everyone know what neutrophils are? Type of white blood cell, okay? And they're the same. And then they have innate immunity. So we can treat them the same. Oh, no, you can't. No, you can't do that. So they extracted the cells without due care, centrifuged them down, exposed them to endotoxin, and so that many of the cells clotted and lysed. Finally, they used the remnants, so they centrifuged down all the rubbish, all the cells, a large number of the cells, and they were left with the cells which were resistant to this technique. And they published in Science at all places, and journals like that. And because the referees had not heard of the papers in the 70s and 80s, and they hadn't read. They hadn't read. They were trying to reinvent the wheel. And I've just written a paper on this, which I don't know what's going to happen. But I don't care at my age, okay? They can say what they like. They're wrong. These scientists are from places like Harvard, they publish it in Science, and they can't do the basic thing of stabilising the cells they're working. Oh, they've got these wonderful techniques. Ah, but the cells are open. So that's the lesson you must bring to literature. I mean, just think. I know one group that has been guilty of this. They've received funding from all sorts of agencies to do this work because the referees haven't read the literature. Because the referees, I mean, I'm knocking on now, but they're not my age. The referees will be more people slightly CSU, more on Alessandra things. There'll be referees for the grants. And they won't have read the literature. And when it's full of how to stabilise the cells. It's appalling.
Did they recognize the mistake later? Did they say, oh, we were wrong in some way? Or is
I haven't published a paper. I did contact one group and I said to them, do you know what you've done? They got money from the Wellcome Trust, you may have heard of, charity in the UK, and from an organisation for advancing the use of alternatives to mice and rats in experimentation. There's an organisation set up which provides funding, and I had funding from that. And I saw where the referees came from, and I contacted one of them, a scientist, who was a full professor. I said, do you realise so and so and so and so? And he wrote back and said, oh, well, maybe we should have done. And he said, anyway, one of our co-authors worked in a Drosophila lab. Because you worked in a Drosophila lab doesn't mean to say you know how to bleed the insects and stabilise them. So when I wrote back and said that, he hasn't contacted me again. So I don't care, what's the point? When he published my paper, when I published the paper, he knows. Okay, next slide, please. How did this happen? Simply because they stopped their literature search at the year 2000. I was in a congress in Italy, an international congress in Italy, and somebody published a paper, and it was identical to the paper I had published. So I saw him and I said, well, why didn't you at least cite my paper? He said, well, my supervisor told me that I shouldn't go back beyond the year 2000. That's ridiculous. Einstein published his papers. It wasn't in this century, it was the previous century. So stop the literature search at 2000. Ignored all the previous publications contained in the protocols of stabilizing the cells. This is the name of my paper. Forgotten Protocols of Back to the Future. I thought that came to me in a dream. Back to the Future. It's exactly that. It is back, and it's for the future. So that was inspiration from this subconscious analysis. Forgotten Protocols for optimizing the isolation of arthropod insects from these insects and mosquito community. So that's the name of the paper, which is published. Next, hopefully that's made a point about reading the literature. Next slide, please. Right, now we come to the papers themselves. We stop at this point and answer any questions. And I'll pause. I've been talking for a long time. No, I'm okay. I'm okay. I'm just wondering about people. They probably, if their English is not perfect, they probably, if people struggling with this too much, you're not going to say, are you? You're not going to tell me. This talk is available. Yeah. You can have this talk, and you can all have a copy of this talk. Okay?
I sent to them.
Oh, so you've all got it. So you can. Right. So we come to actually the construction of the paper, which is what the seminar is supposed to be about. The title. This title can sink or sail a paper. It's very important. The main title should be as short as possible and contain all the main elements of the paper. Short as possible. E.g., the one I told you before, invertebrate, you don't understand that, but it should contain all the elements. That paper contained, it was on invertebrates, phagocytosis, chromatin, and defense. So the key components in your title. So it says invertebrate, phagocytic tracts, ancient defense weapon. All are terms indicating a broad picture. Interesting phrases, phagocytic tract, evolution, ancient defense weapons. Appealing not only to the specialist, but to a wider audience. I know you all wanted to read that paper now. I don't kid myself, okay? Next slide, please. Right, the title, here we are. Here's a paper. I'll read it to you. Some aspects of the interaction of mycobacterial leprosy with HACAT cells, a comparative study with human macrophages and dendritic cells as host cells for these mycobacteria. Does anyone understand that? You can probably understand that. That's the title. I'll tell you what's wrong with it. The title is vague. It needs to give more idea of what some aspects. What does some aspects mean? Also, what are HACAT cells? What the hell is the name of those? Keratinocytes. Are they keratinocytes? The keratinocytes are cells in the skin. So, when we published this paper, when I did my job, it was interaction of mycobacterium and leprosy, which is a leprosy organism, with human keratinocytes, in the field of skin and infection, new frontiers in cellular immunology of leprosy. You can understand that, hopefully. So don't produce that. Try to get it down to a few words as possible. Next slide, please. Summary. Okay. The first point to read in the paper is the summary. Summary is most important. The first section to read by busy scientists scanning the literature. However, it's not the first section to write. Leave writing a summary to the end, because as you write your paper, you find new things, you find new paper, you get new ideas, your subconscious is helping you, and so the paper changes significantly, and your co-authors hopefully help you too. So leave a summary to the end. Paper will evolve as you write it. As you say, new ideas, new data, as you read the relevant literature. So we forget about the summary now. Forget the summary now. Next slide, please. The introduction. Now we come to the introduction. This is the real meat. The most difficult section to write. Okay? You've got to justify your paper. Serves to place your paper in the context of previous work. Justifies why you have done the work. It will show the reader, the informed reader, that you actually know and understand the literature. You can't write an introduction which is relevant and get it published, paper published, if you haven't read the literature, because you missed out all the significant papers. And I've warned you, if you do miss the significant papers, then the referee could well be one of the authors of the significant papers, and you'll get an instant rejection. So it says here, temptation of young, inexperienced scientists, even experienced scientists, to try and cover everything. It's not a review, it's just on your subject area. What is being published, which is relevant to your subject area. Not irrelevant stuff or partially relevant stuff. Next slide, please. Next slide, please. Focus down. Avoid the kitchen sink syndrome. Do you know what the kitchen sink syndrome is? Where you try to put everything in? Next slide shows you the kitchen sink syndrome. Next slide, please. Would you go back? Thank you. The kitchen sink syndrome. Avoid the kitchen sink syndrome. Only include those papers of direct relevance to your subject. It is not a general view. How do you do this? You must know the literature. Read, read, read. It's no use having 500 Facebook friends if you have not read the research published in your area. How many people have got 500 Facebook friends? Anyone? You're not going to tell me. Nobody's going to tell me. 400? 300? 200? Now 100. You're not telling me someone here hasn't got 100 Facebook friends. How many have you got? I think 2,000. 2,000? No comment. Next slide.
But I don't go into my social media a lot.
No.
I read a lot.
I spend all day reading.
Yeah.
Next slide, please. I read a lot, don't I? Right, now this is a bit of a business slide. This is the name of the paper, okay? This is the title. Trypanosoma cruzi causes Chagas disease. In silico and in vitro alternatives for identifying new parasitic agents. So it's about T. cruzi, and it's about anti-parasitic agents, new anti-parasitic agents, okay? So the first paragraph would be an introduction. You've got to explain what T. cruzi is, okay? T. cruzi. You have to explain in the introduction the title, you know? T. cruzi is a causative agent of Chagas disease and is transmitted by insect vectors from Tiatoma. Over 10 million people are affected by this disease and 100 million are at risk. 20,000 deaths occur annually in 18 countries. So that's the first thing. You have to explain the topic. So then you have the meat of your introduction. Previous work by X, Y, and Z has shown that such and such drugs do not work, and these are the reasons they have side effects, blah, 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 blah. Okay? That's the meat of your introduction. Then at the end, you underline the justification. Most important, despite the use of drugs, okay, we talked about drugs, the drugs here, despite the use of drugs to treat pregnancy, these drugs have serious side effects, so that patients abandon treatment. There is therefore an urgent need for new antiparasitic drugs. The present study describes the steps required to identify and develop such drugs with low mammalian toxicity without the use of laboratory animals in silico. So that's the introduction. Explain. 3 parts there. Explain what this is, give the meat, these drugs, what they are, then the justification that they have side effects, and we urgently need new antiparasitic drugs. Okay, any questions on that? Next slide, please. It's always worth looking at the editorial board. I mentioned this. Because you may find, when you're submitting your paper, look at the editorial board, you may find somebody who you know and will be involved in processing your paper. If you find somebody who's working in your area on the editorial board, for goodness sake, quote some of their papers. Okay? Quote seriously. Quote their papers. Not all of them, but 1 or 2. Because if you don't, they might get fed up. And not. Now, I won't say more about costs. I'll say another. Next slide, please. Next slide, please. Right. So that was the introduction. Is that clear about the introduction? What you must do? Right. Materials and methods. Right. Who's this? Next slide, please. Materials and methods. This is easy to write. Easiest section to write. Providing you follow the basic rules. Do not repeat in detail already published protocols. There's no use just repeating a protocol that's been published. But you must give enough information that somebody who wants to repeat your experiments knows the protocols. So if the protocol has been published, you say part of the protocol was published by X, modifications we made are as follows, and then you give all the details of the experiments that you did. Make sure, when I referee papers, or I help you with papers, they invariably have different groups of people, animals, plants, whatever, different groups. And you'd be surprised how difficult it is to follow how many groups there are and what they're doing. So if you've got quite a few groups, put a table in and explain. Or explain clearly. I've dealt with papers which they said that they had 900 animals, I don't know, insects or whatever it is, and they had 5 groups of 19. Well, 19 times 5 is not 19 times 5 doesn't come out to 100 or 1,000 or whatever it is. Make sure that the numbers actually add up. Number in the group corresponds to the number of animals they say they use. I mean, it's such a simple thing, but the numbers are often wrong. Happened last year in UFF, and it took me 2 attempts to get the figures right. Not for me, but for this other person. And make sure it's absolutely clear how each group is tested. It's a table if possible. There are a number of experiments, number of groups. Conditions of dilutions, times of treatments, temperatures, G-forces. You never say the cells were centrifuge at 5,000 RPM. It's G. You never say RPM. It's always G-force. That's a small point. Next slide, please. Right. In order to write the materials and methods, you will need to keep a laboratory notebook with all the details. You need what experiments are done, the dates for experiments, and why experiments fail and were repeated. Sometimes the experiments are carried out over years. You finish your work, your doctorate work, you go and get an appointment to another university, and you want to publish a paper. You will need the laboratory notebook in order to write the paper. And your advisor should check your notebook every now and then and make sure that you're keeping a note of everything you do. You can even include your results in your lab notebook. Put everything in there. We call results of experiments and use statistics carried out. Make sure you always have adequate and relevant controls. Experimental groups and controls. Inadequate controls will guarantee rejection of your paper. Say something about controls. Next slide, please. What is a control group? In science, social science, etc., a control group is a group of subjects treated the same way as the experimental group, except it does not receive the experimental treatment. An example, COVID-19 testing, which half the people receive the vaccines, and the other half, controls, do not. It's then easy to compare the results of these two groups using simple stats tests. Such tests are called double-blind experiments, since neither the subject nor the experimenter knows which person received the vaccine and which had the control. This is the simplest control. Next slide, please. Often you have positive and negative control groups. A negative control group is a control group which is not exposed to the experimental treatment or any other treatment, and that is expected to have an effect. So it's just animals or humans not treated in any way. They could be given PBS, also called saline, or water instead of the medicine, for example. That's still only a negative control group. A positive control group is a group not exposed to experimental treatment, but some other treatment which is known to produce an expected effect. These sorts of controls are particularly useful to validate experimental procedure. An example, if you isolate a new antibiotic from a plant and wish to test its effectiveness, you'd have three groups. You'd have one, infected subjects injected in the test substance, the experimental group. Two, the subjects injected with saline, that's the negative control. And three, with a known antibiotic, positive control. Three groups. So a new antibiotic, three groups, injected with a test substance, injected with saline, and injected with a known antibiotic, because what you want to do is compare the efficiency of your new test substance with this antibiotic. You have to do that in order to get approval by the government bodies for the use of the antibiotic. It has to be that much better than those drugs which are available already. It has to be significantly better. That's why you need those three groups. Next slide, please. Results. Outcome of experiments. X died after Y hours in comparison to the controls. These results, it's no use saying the mice died quicker than the controls. The experimental mice died quicker than the controls. You have to do statistical analysis to prove that, unfortunately. Differences have to be significantly different to each other and to the controls. And the result should be derived from experiments repeated several times, with as large number of possible individuals and groups as possible. Now, in the social sciences and psychology, it's not using human subjects. It's not easy to have large groups of subjects. So you have to do a different type of statistical analysis. You use parametric or non-parametric in social sciences. You would, with small groups, use non-parametric tests. Do you know the difference between parametric and non-parametric statistical tests?
You're starting to learn statistics. They're mostly master students, you're starting to learn that.
Ah, good. Okay. So as I say, most scientific experiments, you use parametric. This would be a normal distribution. Anyway. When in doubt, don't be frightened. Consult a statistician or your moderator and read around the stuff that you don't understand and ask for advice. Because it's not in stats analysis. We're just starting stats test now. So you know it's not easy, is it? Yeah, so you've done some experiments and you've got negative results and you want to publish them. That's difficult. There are journals that do accept papers like that, but you have to seek them out and find them. This is really frustrating. It's very frustrating. All I can say, did you how many times did you do the experiments?
I asked about because I know the teachers have more good results than bad results. I'll think about because it's not my case, not my experience, but
Oh, in general, yeah. Well, if you get negative results, the thing to do is to redesign your experiments if you have time and try and turn things around. Or what you've got to realise that negative results sometimes are very valuable. They can be very valuable. Now, I don't know the context you're thinking of, but they can be very valuable. A positive result or a negative result. We all do an experiment, we think something's going to happen, it doesn't happen. But something else is significant has probably happened as an indicator. So we have to sit down and analyse it. You say, oh, I've got negative results. Throw your book away. No. You have to talk. Talk to your advisor because you may find something there which is very important. It can be very important. Negative results. Okay, next slide, please. Oh, this is all about statistics. And journals sometimes employ statisticians to check the results if the stats is very complex. The referee has a checklist which may ask if the experiments carried out were well designed and the test appropriate. Do not include any discussion in the results. This is a common error. Sometimes, however, you have to explain particular experiments and results, which results you've carried out. For example, in order to analyse the dynamics of antibacterial activity in Ciência, the anterior mid-gut contents tested against different days after feeding. The results showed that. Sometimes you can't just produce the result, you have to explain why you've done the experiment and these are the results. Okay? But that's not really a discussion of the results. That's just explaining the experiments. That's part of your material methods. Next slide, please. Right. Another great problem is making tables and figures. Always consult the instructions of authors. They'll give you all the information you want on the number of figures and the tables allowed. Look at papers already published in the journal. Get an idea about formatting your tables and figures. Look at the previous publication and see how they format them. And the same goes for writing legends. The legend of the results or the table, but sometimes you have to put more information in than in others. So just look at examples of that, of tables and legends in that particular journal. Next slide. Results continue. Big mistakes in tables and figures. First of all, not referring to all tables and figures in the result. Do you know how common that is? I'm reading a paper and it says figure 1, and I look, and there's not a figure 1, and it's so careless. It happens all the time. And there's a list of co-authors this long. Nobody's read the paper. Nobody's read the paper. It's just, it's happens today. You get these papers and all these authors, and the co-authors don't read the paper, leave it to the senior author. No, if your name's on that paper, you must read it. And you spot these differences. I mean, it's such a simple thing, but it's occurring all the time. You quote the wrong table or the figure. That goes all the time. Or you use symbols which cannot be distinguished from each other. They all look the same. Figures are too small, and they describe features you cannot see. This is a problem with electron microscope. Does anyone want to use the electron microscope? No? Not including scale bars, but using magnification in figures. You use scale bars. You don't include magnifications because when you look at a figure and you submit that figure, that figure will be a different magnification in the publication, so that the magnification you give is wrong. So you submit the figures with scale bars. Don't repeat the same data in both tables and figures. Next slide, please, shows you what you shouldn't do. You can't read that, can you? That's what you shouldn't do. I've seen this in meetings, in Thea Cruz and in particularly Thea Cruz. You can't read it. What's the point? You can't read it at all. These have to be figures. They have to be larger, separate figures if necessary. That's an example of what not to do. Not to do this. Next one, please. Discussion. Now you have to interpret your results in the context of previous results and develop new ideas. You've got to develop some ideas from your results. You must be able to distinguish the wood from the trees. Now, do you understand that? Distinguish the wood from the trees. In other words, the trees are there. They look like broccoli, the trees. But you can't see the wood, which is the important stuff. The wood, the trunk. That's what you want. You don't want all peripheral stuff. Distinguish the wood from the trees. Many scientists try and discuss every minor point in the result, especially new people writing. They won't discuss every point. But by now, you should have a pretty good idea of the most important, innovative results that you have. You must. You're already presenting it. And you have an idea of how to develop your research. These should be focused on in discussion. Detailed knowledge of the literature is vital. Must know the literature. You have to discuss your results in the light of previous publications and where your results are in, and the significance of your results, and what the future is. Next slide, please. Read. Next slide. Recent knowledge of the literature needs to be checked out again here. Some years ago, I wrote a paper on flies and antibiotics, okay? And it was the first to describe antibacterial factors in these insects. And there's 1,000 species now. So we found an antibiotic, new species. The paper was complete, ready to send off, and it decided to look at Actrotropica, only to find a newly published paper, which was an antibacterial factor in the same group of insects as I've been working on. And that was almost the day of submission. Next slide, please. But the literature can be overwhelming, especially now with all these journals. Absolutely overwhelming if you work in a popular research area. I use a system, if I've got more than 100 or more publication papers, and I'm trying to provide a plan for my discussion or review. I have a system. My system is I have a PDF or Word copy of the most relevant papers. Okay? And then in the USB, I build up a fresh literature search prior to writing. So I get a PDF or Word document, a Word copy of the most relevant papers. Okay? Next slide. Example. I read the summaries, and if directly relevant, read more, then cut and paste the title and a few sections into the discussion file. I underline the most relevant lines. So I read the summary, and it's relevant, I read a bit more, and I take a few lines from it and the details of the paper, and then I grade the paper with an asterisk, 1 asterisk, or 4 asterisks. 1 which is not significant, and 4 which is very significant. Finally, I look at the highest rated papers, all those with the 4 stars, and this indicates the subject areas for discussion. It's a simple system. They've been classified according to relevance to my paper. I list the main subjects identified and arrange them in order of relevance to my paper. This forms the basis of my discussion. It's a simple system. It takes a bit of work. You've got to have a file, build up a file. You should actually be building up a file anyway. You should really have a file. Then classify the papers. Reread them all, just looking at the summary, and then classify. And it helps a lot. My most recent review had 347 papers that actually included it. So can you imagine how many papers I actually had to read? Next one. This is the most relevant paper. It's got 4 stars. I don't want to read that to you. But this will be what I would do. This paper, I decided was relevant. It's about antibiotics in this fly. And this is the summary. These are the authors. There's where it's published, and there's the DOI number. So I've got that. That's a 4-star. You can have 1, 2, 3, 4-star papers. Next slide, please. This is a 2-star because it's not really relevant to my studies. It's not on an antibiotic, but it's about medicine-resistant stuff. I classify it as a 2-star, where it's published, the authors, and there's some stuff there. But I probably wouldn't use this. Next slide, please. Right. Discussion should finally briefly emphasise the main findings and significance of the paper for future work. For example, to our knowledge, the present paper is the first to show in vitro phagocytosis. These findings may be of great use in the search for new therapeutic agents or targets for the diagnosis and treatment of leprosy. And then, with this work will enable the knowledge going to be extended into study of other types of skin diseases. These are key phrases which you need to include. So include the most significant findings, and then what will happen in the future. Next slide, please. You should now come to write the summary. The summary should be so easy to write now, because you've identified the main points in your discussion. But be a perfectionist. Follow the journal template and near as perfect as possible. And make sure your headings, your abbreviations, look at the journal format. It's H for hours, or HR, or hours, etc. Get the format as perfect as possible. Be a perfectionist. Because if you're not a perfectionist in doing your writing your paper, are you a perfectionist in doing your lab work? Probably not. And as it says here, make sure that somebody in your co-authors reads the paper. That doesn't happen all the time. Otherwise, you may find your paper is returned rapidly for correction or even rejection. What these journals do now, a lot of them in your case, will say, oh, the English isn't good enough. And we employ a person who will rectify the English for you for like $1,000 or something like that. So don't give them an excuse, okay? Because a lot of the people that are correcting your English are not science graduates. And you'll find sometimes the wording will be changed and it's incorrect. Finally, next slide. Never behave unethically. Don't pirate, don't plagiarize or use AI. I did a search on AI and came up with one of my own papers. And there are mistakes. And what happens is, if you're writing a thesis, you'll have a section which you've written, and then a section, and there's mistakes in English, and then there's a section, AI, which English is probably almost perfect. And you think we can't spot that? That's plagiarism. You don't really want to do that. 50% of students are using AI. Fraud. Omit the authors, or omitting authors or inventors. And finally, next slide, you will find out. How many people recognize this? Anyone not recognize it?
Al Capone.
Yes, Al Capone, 1930s, big mafioso boss. And he's put to prison for fraud of his tax receipts. A bit like somebody called Donald, we all know. And if you're not careful, you'll end up like this. The next slide. Okay, that's the finish. Thank you. Oh, I can give you one more slide. Before I came here, I had a haircut. Next slide, please. Oh, okay. Next. Keep going. No, keep going. Next slide. There you go.
Thank you.
I'd like to thank Norma for all the knowledge and all the
Could you please use
Yeah, I'm not using mine.
Could you please use the microphone? Could you please use the microphone?
Maria will be here in the afternoon as well?
Yeah.
Yeah, so we can do that. Okay. We have some gifts for you and certificates and things, so we can give it to you later in the afternoon. I wrote down some doubts and some questions we're going to ask, but we saved that for the afternoon, so hopefully if the students have some doubts, we can discuss this better in the afternoon, okay? We'll have now some coffee and some cake here, and if you like to come and talk to the professor, you're very welcome. And we wait for you 2 p.m. here in the auditorium, and we'll have some YouTube channel recording to do. So, no, after we have this coffee. So, thanks a lot, Norman. Thanks a lot for you for coming.
Maria is my best friend right now.
Daqui a pouco eu vou ter que sair do palco.
Isso, muito bem. Gente, mas vocês estão bonitos, hein?
Agora eu vou tirar o meu
Agora tá o nariz também.
Quer deixar
Porque ela quis. Ela não quer ser
Caiu alguma coisa?
Ela é bem boazinha.
Ela é boa?
Já separou o lugar para deixar material?
E é bom que ela faça as coisas, né?
Cadê sua bolsa?
Ele perguntou quem sabe a diferença entre paramento e não paramento. Eu achei a mão.
então, professor, coloca o carro.
As xícaras eu dou lá.
Aqui, professora, que ela pegou o vaso com uma ínfula, eu falei assim, querendo levar o vaso, o vaso.
Assim,
Alguém vai levar?
Mas também não sabe,
Quem não assinou a questão dos certificados? Todos já assinaram a faixa branca? Tá. Vai estar passando agora, para a turma 2022 e 2023, a chamada da parte da tarde. Tá? Da parte da manhã eu já tirei daqui e já está guardada.
Yeah, they said that they
Good afternoon. So we're starting now in the afternoon. We'd like to thank everyone for being back here. And I'd like to start with just asking if you have some questions. If anyone wants to ask, you should feel comfortable to ask in English, but if you're not that confident, you can ask in Portuguese and then we're going to translate it. Got it? Vocês podem falar em português, quem não se sentir à vontade. Eu acho que é uma excelente oportunidade da gente praticar. Então, quem tiver com vergonha, libera a vergonha e fala do jeito que conseguir. O importante é se comunicar. E aí, se ele não entender alguma coisa, a gente vai reforçar para vocês. Tá bom? Então, alguém gostaria de começar fazendo alguma pergunta sobre a publicação, sobre o que o professor falou? Alguém? You're shy. Okay, so I'm going to ask. Yeah. Okay.
Eu fiquei com uma dúvida quando ele falou sobre publicação, sobre somente resultados positivos. Foi isso mesmo que eu entendi?
No, but he will explain it to you. No, when you mentioned that we should only publish positive results, and they were confused that what if we find things that are negative?
Okay. I did actually answer that and said that negative results can be very important because you have a theory and you test the theory with your experiments, and the answer you get is not the one you thought. The answer, in actual fact, you get may be more important than the original question. So what you have to do is go away and think about why you've got negative results. And it may reveal that there's a different aspect of your work you haven't even considered. Now this sounds like a load of bull, but I can assure you, if you get negative results, you go away, you look at them and you think about it and you run them past colleagues. And you may find something there which is even more important than your original question. Okay. But it is very difficult just to publish negative results as such. But negative results are as valuable, if not more valuable, than positive results sometimes. Okay? I can't give an example. I didn't know that question before. I could have thought of maybe giving you an example. But it is true. Negative results can be more valuable than your original question. Do you have an example?
No, I don't have it. No, I do actually.
We did a research here with ozone therapy in the healing of soft tissue graft on the palate, and we used the concentration of ozone that was bad for the tissue. Actually, it was harmful, and we based the concentration of the ozonated oil on previous literature. But it's a very new area, and people, just like in lasers, people use different protocols, and we got a protocol and reproduced it, and it harmed the tissue healing actually, and it's published in Journal of Periodontology. Ozonated oil with this concentration was bad for the tissue. That's the title of the article, so it's a bad result. I think the point is that if you have a bad result that came from a bad methodology, then you should look over your methodology and if something went wrong. But if it's a bad result and you did everything right, what went wrong? It's a good thing to tell others so that they can not use this concentration we used on clinic because it was harmful. Got it?
Question the original protocol, because the original protocol may in fact be incorrect.
How do you choose the journal, the good journal, to your article?
How to choose it?
Yeah, journal. Give me tips.
I thought I gave you lots of tips this morning about choosing a journal. Good journal for bad journal. Well, you work in an area, okay? You've got a research topic, and you're convinced it's a good topic. So the first thing you can do is to find out the other people that work in that area, if there are other people working in that area. See where they're publishing, okay? And if you're in a team and working on this topic for some time, talk to other colleagues. Then, when you decide on a journal, as I said, look at the editorial board. If some of these new journals don't have editorial boards, or they have editorial boards, which I told you, if they're all from Turkey or all from India, be careful, okay? And actually research some of the editors, some of the people on the editorial board. Look at their papers, see if they're good people. And if you find that, I did this the other day, and I found that the person I was looking at was a senior scientist in that area and published well in it. So that's a good indication. Do your own research about that particular journal. Other tips, if it's a very recent journal, it's likely to be a predatory journal. Find out if they have a waiver policy. A waiver policy for the...
Translation for waiver, because it's when they don't charge.
Yeah.
Or the waiver policy.
It's a reimbursement.
Reimbursement.
A reimbursement. It's not reimbursement because you don't pay in the first place, but it's a way that you won't be charged. Okay? It's a waiver. And they should have a waiver policy. And if they don't, and a lot of, I think the Elsevier journals don't, they're very harsh. Other hints? There's a few hints there anyway.
Okay.
Okay?
Thanks. Anyone? Still shy. Oh, yeah.
Hi, Professor. First of all, thank you for being here today with us. And I would like to ask you, what main advice you would give to anyone who wants to pursue an academic career in Europe?
Down in Europe.
Anyone who wants to pursue academic career in Europe.
Just repeating for people on the internet.
Well, you have an area now, yes? What is your area?
It's dental material.
Dental material. So do you know any labs in Europe where they research dental material?
Yeah, in Germany you have a lot of.
Right. Well, look at those labs, look at their publications, see how many people are in the groups, and apply to the lab with the best publication record, and maybe the same person is the lead. Sometimes the publication, the research student is the senior author, but invariably the last person is the senior author, the person who instigated the project in the first place. So check out which of the people in that lab, in that publication, is a senior one, and write to them.
Yeah, but when I should write to these people for the professor in Germany?
Anytime you want to. And there's no time, right time or wrong time to do that. It's really more up to your timetable. When are you in a position to travel? When are you in a position to go? You may get an offer, or you also have to, in your letter, you have to clarify what you wanted to do. It's no use writing and saying, would you like to collaborate? You want to say, I'd like to collaborate. I've been working in this area and I found something very interesting maybe, and I would like to pursue this further. Do you have any postdoctoral positions or doctoral positions in which we could collaborate together? And I could spend some time in your laboratory. Because the people are very, very open to receiving people from abroad. I mean, you may often find some labs in Germany working in this area who are from Brazil. Now that's a lucky find, because they'll be more sympathetic towards you. Brazilians will look after Brazilians. But do you have any particular town or city in Germany in mind? München.
Yeah.
München, southern Germany. Southern Germany, yeah?
Yeah.
Yeah, very nice place. Wonderful place to go to.
Yeah.
I must encourage you. I love Germany.
Yeah.
I worked there. I worked in Hamburg.
She speaks German.
He's trying. Sprechen die Deutsch. Yeah, so focus on that area. Focus on that town, on that group. But not only them, you must find out the best. Go for the best, because the best will then be the best to support you and the best to help you in your career. Because you want the best person when you go abroad, to when you leave, when you finish, to give you a reference, because you're going to have to move on somewhere else, maybe come back to Brazil. But then you'll be in competition. Research is competition. It's massive competition. We're normal people, we compete with each other. In the UFF, people compete with each other, I assume. I mean, they're all friends here, that. But you know, some people want to get promotion to do this, some people want to do, and sometimes it doesn't work out. But pursue the best you can find. Okay? And if you can find the Nobel Prize, now that's really gold, okay?
This is something
Important. Any one of you who wants to go abroad or who has contacts in other universities, we must formalize this partnership so that you can go to what we call here sandwich PhD. What do we call that in English? Combined PhD, half in Brazil and half abroad. Here we call it sandwich.
No,
Do you have a name for that? No.
Sandwich PhD in the UK is half in the university and half in business, in industry, okay?
It's different.
It's different.
Yeah, but if we want to make this partnership, to formalize it, so that the students stay half the time in Brazil and have 1 year there or half the time there, it's possible.
Yeah, well, what will happen if you get a positive result? The German colleague will be in a position, if he wants to apply for funding from the European Commission. And the European Commission has a large amount of money for collaborative research. There's different names, different schemes. But finding your way around the websites of the EU is quite difficult. So another thing is, do you know anybody that has a joint EU grant with somebody in Europe? Do you know somebody? Yeah. You do, because you talk to them, because you need to get advice on the forms, because the forms are terrible. And you end up with filling forms like this. You need some help, you know? So don't be frightened to ask people to help you. Because I had help when I was applying for grants. I had help from people, a lot of help. The sort of help I got was that my professor at the time, when I talk about Professor Newkey, I mean a professor, titular professor, he had applied to his research council throughout his career and never had an application turned down. So he used to show me some of his grant applications, the actual applications. And you can get a feel then for what they want and what they don't want, and that person can also talk to you about it.
The universities abroad, some of them charge some tuition fees for foreign students. You know what that is? Uma taxa que se cobra dos estudantes internacionais. Algumas universidades não te aceitam de graça pelo seu sorriso. Elas exigem uma taxa que a gente fala tuition fee. Do you know if we can get rid of this tuition fee by making these partnerships with the universities, or if they're going to charge us every time? I don't know, maybe it's different for each university, but in your university are there tuition fees for foreign students?
The answer is yes, but they're usually for undergraduates, not with postgraduates. With postgraduates, they can actually apply to the university for studentships. They're called studentships, and they're for people to do their PhDs. But the fees referred to are for undergraduate, for the first degree, for the BSc or the BA, rather than for the postdoctoral position. The postdoctoral positions, the university funds themselves or has a grant with funding for that position. So what level are you at? Are you a postdoc or PhD?
So you're going to go for the PhD, you want to go abroad for the PhD. Yeah, well, you need a studentship, and it shouldn't be fee orientated. And in Germany, everything is free. They don't charge fees for undergraduates or anyone else. So you've chosen a good country to do that. But as I say, it's not undergraduate. In Swansea, where I come from, PPGO, only the undergraduates from abroad actually pay their fees.
No. I have a question from Professor Flavia Maia. She said that she's working as a reviewer for some papers, and what do you think are the most important things to check? You already told some things in your presentation, but what are the most important things when we are reviewing a paper?
When you're reviewing, you mean when you're having a paper reviewed, or when you're the referee? What would I look for? Well, if it was a review, I can tell you from experience, and a lot of you have to write reviews. Is that correct? And sometimes they come past me, and the first thing I do is I go and look in the internet and see if that person has identified the leading papers in that area. That's the first thing. And if I find very relevant reviews, which the person has not included in their paper at all, I will reject it, because it means they haven't read. Do you remember what I said to one? Read, read, read. You have to know what is going on in your area. Otherwise, you're duplicating someone else's work. And I find a lot of duplication. It's very tough for you people to write relevant reviews at your stage, because you don't have a knowledge which goes back many years of previous papers. So you actually have to dig and find out what is going on. You must know the literature. And as I say, with reviewing myself, and I receive a review to referee, that's the first thing I do. I look to make sure that the relevant area is known by that person who has written that paper. And that applies not only to reviews, but to other papers as well. You've asked me, for example, to review someone else's English in a paper, right? That's a paper, it's not a review, is it? It's a paper. Well, the first thing I do is I look at the subject area, see if I know something about it. If I do, that's helpful. But if I don't, I will go and I will look at the literature. And I will read some of the literature. And then when I come to read the paper, I know something about it. So I will be able to make a judgment of that paper. And I suspect that a lot of reviewers are not that careful. Some are much more careful. Some reviewers, I had a paper reviewed recently by a German colleague, and he criticised the punctuation, with commas were here, the word was spelled incorrectly there. That's not really the job of a reviewer. The reviewer is to look at the science, the structure of the paper, and the science, make sure it's relevant and is written well. And then in the structure, you don't want to make silly mistakes. You must have all the controls done. We were talking about before, the right controls. You must have some stats done. And your tables and your figures must be easily reviewed, easily looked at, make sure that all the labelling is correct, and make sure the font size is correct, the legends are right. There's so many things when you do a review. Each paper is different. But there's a lot of carelessness. There's nothing more annoying than seeing carelessness, where the person, the author, doesn't actually, the number of groups, the number of animals in the groups, they don't add up to what is written in the materials and methods. That is a common mistake. The materials and methods spell out the groups so anybody can understand it. Because sometimes the groups are very complex. They're not just 2 groups, they may have half a dozen groups. Then it's difficult for the reviewer to know what is going on, because when the results are presented, they say group 6 and group 4 and group, and it really is difficult. Clarify everything in the materials and methods. And if So I get as far as the discussion. Well, I look at the introduction next and the justification. Is there a justification for that paper? You must justify it.
Like you said, there are a lot of predatory journals, and we receive emails every day to revise it. And you just said we should not be referees to revise English. English should be already done, reviewed. And I often receive, and he mentioned the Turkish and the Indian. That's not because we have some prejudice against the Indian people or Turkish people, but mostly Indian journals, they sometimes send me things and I'm curious and I open the papers and they are completely wrong. I think Google Translator would have done better. And nothing goes with nothing. I said, this paper cannot be reviewed. So have you ever seen things like that with gross mistakes and things that you sent back to the, or refused the paper?
I tell you, there is a growing habit of people, of authors sending out papers which they know they're not written well, and they're looking for the referees to actually rewrite them. And some referees do that, but that's a growing problem. They send the papers, they know that they're not written properly, and they know that the referee will try and sort out the English. I end up rewriting, when people send me, when colleagues send me papers, I end up rewriting sections. I'm not going to do that for UFI here now. I will read the English and make sure it's right, but I will also look at the science. My job is not as an English translator. My job has been, it's not now, but it has been, to look at the science and make sure the science is presented correctly with all the caveats, all the conditions I mentioned this morning, justification, and then in the discussion, the future, the most significant results, and what the future could lead to. That's my job.
Anyone needs help with English and with translation to check, because some journals demand that you have an English translation certificate, not by an English teacher, but by a native speaker. So Professor Norman is qualified to do that, and he has been doing that for the post-graduation for many times. So if you want to check, it's not his job to correct everything, and so it must be checked by all the authors. One important thing for our master students mainly is that you said in your presentation as well. People write the project, and then when they're going to write the final paper, the final results, they just copy the methods and the things they did, and they replicate the title, and they don't think about a title that's attractive, that calls for the best results. And that's one problem as well, because you must not replicate the project and I'm going to for my public dissertation or thesis, and you keep the title. No, if it's the bad thing, a nice thing, you should highlight that, and that's an important thing for acceptation as well.
And the one thing you mustn't do is plagiarise. That's a common problem. Actually, cut and paste. It's very easy to cut and paste and write a paper. And as we mentioned this morning with artificial intelligence, AI, there's an increasing amount of it. And as I said, you will be found out one way or another. Okay?
We already have programs to catch plagiarism, or if you copied things for other people, other articles, and with artificial intelligence as well. So it's a helpful tool, but you have to give the commands and to use it in a way that you don't commit any, I don't know if it's a crime, but to make a dissertation or a project, everything done with the artificial intelligence, it's very new for us, actually. And we're as professors, we're learning how to deal with projects and things and presentations that are made with artificial intelligence. Do you have any experience with that, Norman? With students using artificial intelligence in a bad way?
Not at the moment, no, it's too early to tell. But one thing that there is, many of the journals actually run the papers they receive for plagiarism. They do that themselves. And if you plagiarize, the journal will know. They run the text through the system. As for artificial intelligence, I Googled a subject once and I got my own papers back. I couldn't judge it. I don't know. But I do know that I can recognise when the style changes. Now, you can't produce a paper completely from artificial intelligence. You're going to have to write something there. And if I look at that and I see that you have no idea of English or there's English mistakes, and then I look at the other parts of the paper and it's perfect English from artificial intelligence, it's very obvious. Big red light.
You talked about impact factor, and this is something that often people from Brazil forget to check. We look at qualis from CAPES, and there are a lot of journals that are not listed there, and they are high impact journals. So when you are going to submit, you're going to have to check for the high impact. But we come to a problem, because if we don't have a lot of grants, if you don't have money, if you don't have funding, it's difficult to make research in this level to publish. For example, you cited Nature, where you published sometimes, but it's hard for us to get there, and we end up submitting our research to national papers and to, do you think it's valuable to write it, even in Brazilian journals, but to write in English, to try to reach, because we have some nice journals that are B1, B2, and that allow us to publish in Portuguese and in English, so it gets some visibility, because if we don't publish, we don't get grants. So we have to publish to submit to FAPERJ, to submit to CNPq, so if we publish only in Portuguese, we're going to be limited in the grant, get it? So do you think it's valuable for us to always try to publish? Because it's like we're chasing our own tail. We want the grant, but we can't do the best research because of the funding, because of the laboratory cost. So what can you say about that?
I hope. That's a difficult problem. I keep coming back to this. You've all got advisors, yes? Yeah. You've all got advisors, right? Use their experience. That's what they're there for. They've been publishing. They should be able to assess the project you're doing and your results you get, and advise you whether you should publish in this journal or that journal. If you had problems with that, well, you can always ask somebody else, and maybe you'll get advice from them. I mean, this one thing I actually do when I referee a paper with somebody is I always assess it if in actual fact it's at the right level for that journal. And you may think that your project is not at a certain level. How can you judge that? How can you judge the level that you're actually producing the paper? You have to take external advice. You have to talk to your advisors. And if you can't talk to your advisor, talk to someone else. Alessandra, for example, or if I'm here myself, I can advise you. If it's just sending a paper to one of us and it's on a subject and you don't know the level and you've taken advice and you're still not clear, then if you send it to one of us, we don't necessarily referee the whole paper, but we might be able to tell the level and whether your results are significant enough for a different journal. Maybe. But if it's not in our area, that's difficult for us to do. But if it's in the dental area, then send it to Alessandra.
Any questions? No? I'd like you to discuss something about the importance of teamwork. Because once we have no money, we can work alone. And one thing that happens in the university is like, we are here in Friburgo, and we don't know what people are doing in Niterói. We have a lot of lab structure, we have things we can do in partnership, and in the same university, sometimes in the same campus, people that are here in the university working next door, they have the equipment we need, but we don't talk to each other. So this problem about cooperating with the research of other colleagues, how important is that?
That's obviously very important, and the answer is quite simple. Every 6 months or a year, you should have a sort of mini meeting which people produce papers, make presentations, so that people know what other people are doing. You don't have to just give oral presentations. You can produce poster sessions or things like that, or even just make it online. You could have an online meeting every year or 6 months with people, all the people involved, and then you'll find out what your colleagues are doing. I'm amazed that there are labs that don't know what each other are doing. Oh, that's amazing.
That's the importance. Most of you here are dentists, right? No, Fatima is a biologist. Who here is not a dentist? You are, Diana is a doctor. You are? What? I'll have people work with speech. What is that? The speech disorder? Phone? Speech therapy, yeah. But we have in dentistry the SPPGO, the Congress for the Brazilian Society of Research, and it's a must go for all of you, because you can see what other post-graduation programs are doing all over Brazil, and you can cooperate, and you can exchange emails, and you can maybe do some work with people from São Paulo. They are extremely rich. Or from people in Rio as well, people from UFRJ, they have much more money and grants than us. Then it's nice to have that partnerships.
How often do you have these congresses?
Once a year, every September.
And that's for the whole of Brazil, or just for?
The whole Brazil goes to Campinas, São Paulo. Yeah. And it's a nice exchange congress. It's very nice. And it's, you can see what people are doing all over Brazil.
I think that's very good, but I think you also need to have smaller meetings. Yeah, just within the confines of here and Niterói. Just for local people, rather than waiting to go to Campinas to find out what someone is doing in Fortaleza.
Yeah. That was the idea that we had, to send forms to the post-graduation programs, Google Forms, to the professors, and say, what is your area of research, how many students you have, what's your structure, to see if they can share something with us. Because sometimes we have ideas and we want to do things, but we depend on others, on techniques and things that we don't have here.
The problem is if you send out forms to professors, they're pretty busy and they're unlikely to fill the forms in. It'd be much better if you could ask one person to go around and talk to people briefly, Is that possible?
What? To talk in person?
Just talk in person to this group and say...
We must schedule a meeting one day, one morning, to be there in Niterói and to talk to people.
Yeah. So it's communication. That's what it's about. You must communicate. You can't have people working in the lab next door if you don't know what they're doing. Because they may be doing your experiments. You may be able to collaborate together. You may be able to write grants or papers together. It's all about cooperation research, not hiding away somewhere in the mountains and forgetting about the life occurring in other places. And one thing you must remember is you may have a good idea, but I can guarantee you one thing, which I said this morning, somebody in Mongolia or somebody down in the Seychelles will be having a similar idea. So make sure if you do have a good idea, you work on that idea and research it and see what's been published and develop it.
An important thing for master students is to see that the thing that you're doing, that you're working with, must be something special, and it must be something well done. Because if it has a methodology that's right, if you do everything correctly, it's going to be important. And it's going to be published in a good journal. So you must think over your project a lot before you start it. Some of you want to start before you have thoroughly read, like Professor Norman said, you have to read, and then you make your hypothesis. When we come to the seminars in December, we discuss that. What is your hypothesis? And I asked that to students that were already doing the research. And they kept thinking, what is my hypothesis? What am I looking at? And it's something we must ask every day. Questions? Questions? So, yeah?
What are the most important quality or skills you believe one research should have?
The most important qualities or skills for a researcher?
Being stubborn. And not taking no for an answer.
You know what stubborn is?
Teimoso. Because I've known academics who have written grant proposals, and this is a fact, they've submitted them to the Research Council, and they've been turned down, and the response has been not, oh well, I've got to do it. They've actually phoned up and told the Research Council to F off. I mean, this is ridiculous. I've actually known a researcher that went to the headquarters of one of the research councils outside and was waving his umbrella around saying, why have you refused my grant? This has actually happened. Academics are crazy, you've got to realise that. We're crazy people, we're obsessive people. You've got to be obsessive to be a good researcher. I mean, one of my most important previous professors, when I did my cancer research with, he didn't want people coming from happy families. He wanted people that had to prove something. And he recognised that in me for some reason. Because I tell you this now, I couldn't read and write until I was 9 years old.
Did you like that? He had some dyslexia problems and he couldn't read or write until he was 9.
So there was an examination at the time for 11-year-olds to decide whether they went to a good school or it was called a technical school, where people learn to use their hands rather than their brains, which is ridiculous. And I was told more than one occasion that I was pretty useless and I should never go to university. And I was so shy, what's the right word, shy, I was lacking in self-confidence so much that when my best friend got married, when I was the best friend for my, when I was the best man for my friend, when he got married, I couldn't make a speech about him. I was too shy. And what did I do? I became a university lecturer. So, but that's remained with me. That deprivation earlier on, and the fact I couldn't read and write, and I was told I was useless. When people are very young and they're told these things, it stays with them, and it comes out when you're in the 40s and 50s. I think I was a member of Senate, which is the governing board of the university. I was still very nervous about speaking in front of all my colleagues. And that was because of my problems when I was younger. So, you've got to be obsessive. You've got to be obsessive about things. And I mean, when I was younger, I ended up working with insects, but I've done lots of other things. I used to collect insects. I used to go out after school and go around the local parks and collect caterpillars, larvae. Okay. Beautiful butterfly or moth would have emerged. That's how I got interested in biology, and I became obsessed with it. And I became obsessed with working with the blood cells of insects. I mean, what are all the stupid things to do? But I told you, a colleague of mine got the Nobel Prize for doing it. So you can never tell. That's another lesson, actually. Because your project, to the normal people outside in the street, doesn't seem to be of any use in society, doesn't mean to say that that is not very important. I mean, ask a person in the street, what do you think about those little flies around the bananas and so on? They're useless skills. That work on it resulted in a Nobel Prize and a better understanding of the immune system in humans, and new therapy and new drugs, just from those little flies. It's unbelievable. I'm glad to say it. I went to work in his lab for a week, and I sent one of my best postdocs to his laboratory.
Anyone here works with animals? Anyone's doing any research with mice? Fatima is going to start. Anyone else? You do as well? No? It's in vitro study, right? Because we were discussing this earlier, and I learned something today that I didn't know. That just like Professor Norman said, from this study with insects, they discovered something about innate immunity that they could use to study the innate immunity, the neutrophils, the white blood cells of mammalians. And I've worked in my master and PhD with neutrophil activity in periodontitis patients. And he was advising me, do you know, we want to start some study with mice now here in the university. And he said, do you know you can work with insects? And I never thought about it. What? You can study neutrophils in insects to see the stimulation of inflammation or inflammatory markers or something like that, or therapies or test drugs with the blood from insects. And that is amazing to notice, because I feel bad about killing a mouse, but I don't feel bad about killing an insect. Do you feel bad? I'm going to be sad to kill a mouse, but to kill an insect, so that's very interesting for us to know that. And with this exchange, that's why I learned that. I'm going to learn more. I want to read the papers so we can, because explain that thing of the insect growing in the jar, which you just mentioned, how you grow the insect.
Oh yeah. I mean, one thing you can Google or look on the internet on it is something called the Galleria model. You know Galleria, where you go and do your shopping? Well, it's spelled the same way, and it's pronounced simply. Instead of it's Galleria rather than what you say. Gallery. Gallery, yeah. How do you pronounce that? Galleria. Galleria. Well, this is Galleria. So it's the same spelling. Galleria model. And you'll see that all sorts of experiments have been done by injecting pathogens into Galleria. And this helped with the development of therapeutic agents. Galleria model. Oh yes, you asked me these are Galleria, okay, I'll describe them. I did have a picture one. They're about that, what's that, 2 centimetres long. They weigh about 200 to 400 milligrams. But you can wrap them around your finger. And the beauty of them is you can take the blood cells and you can stabilise them, and you can do experiments with them, or you can inject directly into the insect, and you can look at mortality rates of different drugs you're testing, of new antibiotics, for example, or toxicity studies. This has all been done on a large scale, and the beauty of it is this table here will be enough to support a dozen or so big jars with screw-top and caps, in which you can grow these insects. And all you need is some bran and a bit of wax from old beehives, and you have a formulation, and you put the formula into the jar. You get some females to lay some eggs, which is very easy, and the insects grow at 25 degrees, and you can harvest them in the final install and use them for experiments. And the cost is not high. The cost is very low. You can use groups of 20 to 30 insects, and you can have a production line. And you don't need an animal house, whatever you call it. An animal house to grow mice and rats. But it's not a complete replacement for mice and rats. It's a sort of intermediate step between the in vivo experiments and the mice experiments. It's almost almost it's not an in vitro, but it's an intermediate step, which will give an indication for you whether a drug is likely to be toxic in humans or not, by using these lowly insects. And at the moment, there's a great deal of pressure for us to find alternatives to using vertebrates for experimentation. And there's money available for you to develop these alternatives. But this alternative with Gaviria is already available, and it's very easy to set up. And there's somebody in UFF who actually grows them now, and is experimenting with them. So just look at Gaviria models, and you'll look at Gaviria models now on your phone and see if you find any interest.
And we already have a new Finiteroy labs working with that have this.
Yes, there's a lab working with them already. I don't want to say, I'll tell Alessandra more about that later.
I have one question. I never worked with experiments in animals, but I have a question. Because we are making a smart review in animal studies, and for one kind of experiment, many authors use different models, animal models. So I would like to know how I choose the better animal model.
How to choose the best animal model. She's making a systematic review, and each research uses a different animal model. Let Norman answer that, but I have an answer for that as well.
There are different types of models. There's computer models and there's proper models. You're probably including computer models because there's all sorts of computing going on producing models. But the number of models, number of animal models is restricted. I mean, you can use chimpanzees, but you wouldn't want to do that, and you can use ferrets for influenza. You can use rats for cancer research. You can use mice for cancer research, and then you've got a few insect models. The number of models is not that great. Oh, then there's zebrafish and Chemorhabditis and a worm model. Now, how do you choose which model to use? That's your problem. What is your project you want to do?
She's making a systematic review. So I think how to approach. You should have an inclusion criteria that you would separate this analysis for the models, chimpanzee, the mice, the insects, because you can't compare one with the other.
No, it's simple. All you have to do is read the papers on each model. You'll see where they're being published, and the mice are being used for 1,001 different experiments. Chimpanzees are being used for much more limited experimentation, and dogs as well, for limited experimentation. And you'll see, and you wouldn't use lots of pathogens in chimpanzees. Well, you couldn't, because you couldn't have groups of 20 chimpanzees and do experiments on it. It'd be too expensive. So why not use one of the invertebrate models? But if you look, just list the different models, look at the papers, just list what sort of projects are going on there. This problem will be solved yourself. It's like I said before, you have to make these lists, and you can put asterisks and put the different model and the different type of project together.
But it's impossible to make a meta-analysis. Sometimes you can't compare the results because it's about different things.
It's one problem we have, because there are many models and we can just compare the findings.
And depending on the topic, you won't come to a conclusion. It's possible to reach a conclusion based on the literature that we have. So it encourages us to see what's the best model and to do some research on that.
I mean, the best models usually have a genomic input. They know the order of the genes, and so when they're used as a model, those genes are studied, and you can see the full effect of the experiments that have been carried out. So you need to have the genome. and Galeria has a genome. It's got that. Drosophila has, and obviously chimpanzees and zebrafish and King-of-Red-Diamonds. Most of these models, all the genomes are known, so that's most important.
I have a question. When we are working with studies with insights, do we have validation like we are doing this with humans?
If we can compare the results from insects to humans.
Yes. If we do a study with insects, we have to reply after with humans to get a validation, or it's a...
Oh yes, yes. No, you go from an insect model, then you'll go probably to testing some mice. But you save so many other mice lives because you've used the insect as an intermediate. Then you go from mice to the human. But very often what happens in mice is not relevant to what happens in humans. And what happens in the Galeria, for example, is more relevant to what happens in humans than in mice. I mean, because they have this shared innate immune system, something to do with immunity.
It has been long discussed in periodontology. Sometimes what we do in mice relating to blood cells or immunity, they do not correspond to human response. It's different when you're working with mice for the teeth, for example, Fatima, it's okay to use the teeth, but with gum or periodontal tissue, or with periodontitis induced with ligatures, that's not the same pattern of bone destruction. So you must check what are the limitations to use the animal model.
The great advantage of the Drosophila model is that they have all these mutants and they can knock out specific genes, and you can see the effect of knocking out a specific gene on the infectivity or in response to a drug. So Drosophila is very important, but it's such a damn small animal. It's much better to use something bigger, which is Galeria, and they're going to produce mutants now of Galeria, which will allow you to knock out specific genes.
So what do you want to ask? You want?
Então, falar português.
Okay.
Queria perguntar para eles, claro que a gente, quando faz uma pesquisa, gostaria de publicar em revistas de alto impacto, né? Mas seria, acho importante também as revistas com impacto mais baixo para quem está iniciando na carreira científica.
If you think it's of value to publish in low impact magazines for researchers that are beginning, or their first publications, or their master thesis, if you think it's valuable to, because if you're starting, you won't be able to publish in a high impact. But what do you think of that?
Depends on your advisor.
Remember, low impact journals are still going to charge you. You're going to pay to publish in a low impact journal? No. It'd be insane, wouldn't you? Because nobody will read it and you will be $2,000, $3,000 lost. So you must try and develop it and for a higher impact. And don't assume because you are beginning that what you do is not relevant and is not. I mean, you have new eyes. It's an advantage of you people. You're young and you don't think the same as a person like me. I've been brainwashed to think in a certain way. You haven't. You can innovate. It's easier for you to innovate than it is for me. This is the theory. Anyway, so no, don't do that. Don't publish in low impact journals and don't pay the money.
Anyone? Norman, what do you think are major differences that you see in the university? No, you already talked about that in the YouTube recording, but I want them to listen. What are the major differences between the universities, for example, Swansea and the universities in Brazil?
Well, the universities in the West, the UK, whatever you call them, they receive more money. I mean, when UK left the European market, which is stupid because we used to receive masses of money for joint projects. And if you're in Europe, then you have all of the European granting system at your fingertips, and it's a lot of money. And when you get a grant from Europe, and it's also the UK, you get something called overheads. So you get a grant of a friend of mine just got £500,000, okay? £500,000, 3 million reais, okay? And in there was an element between 25 and 40% called an overhead element. And that overhead element went to the university to pay for the lights, to pay for the technician, to pay for repairs in the university. So there's an immediate impact of people getting grants from these organisations on the university itself. So that's one of the big differences. I suspect you don't have overheads on your grants, do you? Other differences are actually the students as well. There was a time when the universities in the UK there were about 40 or 50 of them, okay? And Swansea was one of them. Maybe there were a few more. But then a conservative government came in and they started to decide that everybody should try and go to university. So they started opening universities everywhere. And there was a cartoon in one of the main papers, probably in the Times, which showed a men's toilet with Margaret Thatcher. Do you know Margaret Thatcher? She was the Prime Minister of the UK 20 years or so ago. And talking to one of the ministers saying, well, maybe we can turn this Danero into a new university. That was a joke. And I was wonderfully surprised when I first started to teach you people, because that was back in, 91, 92. And I found that you people were much more interested in your topic than the people who were just marking time and going to university because it was the thing to do. You wanted to go. You had to take exams. Well, these people still had to take exams to go to the UK. But your level and your demand on you to get to university was much higher. So you people are if you like, the creme de la creme. And it shows when we talk together, because when I lecture to you people, I get input from you, I get questions asked, and I walk around, and I don't feel as if I'm working. It's a pleasure to talk to you. In the UK, this is not general, but often in the UK, you'll have 200 to 300 people more in a class, and you look around and you see people going to sleep, and the exam results are poor. They're just there marking time because the parents said they should go there. They're not motivated because they're really interested in a subject and they're obsessive with something. You people have got to be really motivated because you have all sorts of hurdles folks you get here. And sometimes I think you have to go to work and earn money to pay for your hurdles, take time out to work. We still have that, we have that now in the UK, that some of the students are working. But your motivation and your standard, to me, making a judgment, is better than in the average university in the UK. There's some really good universities like Oxford and Cambridge and Imperial College in which that doesn't apply so much because the competition for that is much higher. But generally speaking, these people are really a pleasure to teach. That's one main point for me.
Yeah.
And also, something else is the fact that I am not in competition with your professors, so I'm not regarded as a threat in any way. Professors have competition between each other because some of them want to get promoted, some of them want to get grants, and so it's worldwide. There's always competition. Big competition with you to get into the university, competition for you to get your PhDs and then find a job. It's complete competition all the time. But I find now I'm not competing with anybody. I'm just trying to help full stop.
This was an important thing you mentioned, that you have to be passionate about what you do. Because if you're not passionate, you're going to abandon it, or you're going to do it not in a good way. And he complimented you and the students he found in Brazil. He said, you're very committed, you're very interested, you really want to learn, and he noticed that once he got to Brazil to youth in Niterói. And I'd like to, I don't know if people have questions, because I wanted to have a last question here, and then we can have a break and then maybe have a cup of coffee and go to a last speech, like some presentation. But what's your motivation to be here? You're retired, you were in the beach with your wife, and you're at your house reviewing papers and still advising for research. And every now and then I tell my husband, I want to retire so badly, and he says, Alessandra, that's impossible. That will never happen, because you love to work, you love to be with your students, and that's true. I love them. And I think to be with young people makes us alive and makes us learn more. So your motivation here to be here for these young students?
I'm obviously an obsessive person. I've been doing something for 50 years, and I would find it very difficult to stop. I'm also incredibly interested. I mean, I look at the news every day. I know what's going on all around the countries, all around the world. I'm interested in sport. I used to play squash just before I retired. I won a squash championship for people my age. I'm interested in health. I wrote a book in my spare time on health. I love gardening. I talk to my roses. I'm just interested in everything, you know. And my wife supports me on this, and she often drags me away from the computer and says, it's time you've got to go down to bed. But I creep up sometimes, and if I've had one of my ideas for the title of a paper or something, I'll go and write it down. I have friends who have retired from academia, and what you've got to realise is that poor old academics, poor old members of staff, poor professors, they not only have their research to worry about, they also have administration to do, and they have examinations. I must tell you this, there's nothing worse than having a class of 200 students, then they set exams, and they have 3 weeks of examinations, and you get piles of paper like this, which you've got to mark on the same topic. It's soul destroying, and that's what professors want to escape from. They want to escape from administration. I used to be chairman of the equipment committee in the university, and I used to give out money for equipment throughout the university. But it's so boring, you know. I was asked many times to be head of a department in my university, and I refused because I thought I had more to give by teaching and doing research than for sitting and dealing with the promotion of a technician or travelling expenses or the fact the air conditioning isn't working. Helena Castro told me some time ago that she was dealing with the air conditioning units in the new university. And you know, talented people who are interested in research, they don't want to do that sort of thing. But there are people who like that because it gives them power. They're the people that actually make the rules in the university. We'll let them make the rules, and I'll live by my rules, but I don't want to do bureaucracy. I don't want to do that. I don't even particularly like reviewing papers, but I'm also aware of the fact that at my age I have to keep my mind working. And as I said, I do have colleagues who've got sick and tired of marking exams and bureaucracy. And as soon as they retire, they want to retire, or early retirement, they're in cruising. And my colleague, he's been on about 30 different cruises all around the world. Well, Mary and I have been on a couple of cruises and we love, but they're just for 7 or 8 days, you know, nothing more. And she'll tell you we spend most of the time in the gym. I spend most of the time in the gym trying to keep fit. So that's my motivation. I mean, I'm at the age where Alzheimer's might creep up on me one day. And I'm glad that I managed to get through my lecture this morning because I haven't lectured for 5 years. I'm thinking, well, I'm 5 years older now. And is my mind going to work again? It seems to be functioning, so.
Anyone?
Yeah.
Yeah.
O que acontece? A minha graduação, na faculdade, não tinha um perfil de pesquisa nem de publicação. Não incentivava o aluno na graduação a publicar e estudar. A partir de que
with formation. He didn't have any support or any, no professor said that he could start doing research. He didn't have this initiative in graduation courses. When do you think it's important to start to give the students this scent for research? Since undergraduation or after it? When do you think it's better? Because we have in Brazil 630 dentistry schools. Did you know that? 630. We must start closing faculties because there are 50,000 dentists every year in the market, and the post-graduation courses are full. And for sure, you're going to have a lot of jobs in universities as professors because they're looking for people with PhDs, that do research, that goes after grants. But going back to Marcelo, and when do you think it's important to start to have this look at science?
Well, what should have happened when you were being taught, being lectured, information on research should have been incorporated into the lectures. And that is a time that you should have started thinking about research for yourself. I mean, I keep on about the story with the fruit fly, you know, and I keep telling that because nobody believes it. But it's something that helps people to realise how rewarding research can be and how unusual. And you should be stimulated by your lectures. I'll tell you another story. When I went to Swansea University, I went there to do geology. That was the degree I wanted. I wanted to do a degree in geology. I did zoology and botany with it. And in the second year, half of the geology students disappeared. They failed their exams, then disappeared. And I thought, oh, 50% chance here of not continuing. But zoology was easier. They were easy people. They didn't throw people out the way they did in geology. And so I went to, I was a coward. I didn't pursue what I thought was the correct degree. I'm glad I did that, but the geology department was one of the finest in the world. And the professor who's the head of that, students used to come from far and wide just to hear him lecture. His name was Professor Frank Rhodes. After a few years that he taught I was head of the department in Swansea, and I went to his lectures when I didn't have to. He was appointed to the principal's job at Cornell University. He became the president of Cornell University and an advisor to the governor, to the president. And his lectures were outstanding. They fired me up. It made me interesting. Fortunately, he was working on fossil invertebrates, so he wrote books on fossil invertebrates. So he fired me up to be interested in that particular area. So it's really the type of lectures you get should incorporate some of the greatest research and should also be of enormous interest in some way. There should be some effort made to get through to the student, to try and reveal to them the world of research. It's not just, oh, I'm going to take this and...
Dentro da forma, você como é que era ao longo. Mas dentro da forma, a gente tem um cenário em que as universidades particulares formam um profissional para atender clinicamente, enquanto as universidades públicas formam pesquisadores. Então, quem cursou uma universidade pública, por exemplo, vai tentar ingressar no mestrado, está muito melhor preparado do que quem vem da universidade particular. E aí, quem faz a universidade particular e tem o interesse pela pesquisa, fica meio sem ter ponto de partida.
She says, we have in Brazil different backgrounds for people that graduate from private schools and from public schools. Public universities prepare better students for research. I think that goes into what Marcelo said. When you go to private universities, they prepare professionals for the market to work with speech disorders, or to be dentists, or to be doctors, to be biologists, or things like that. And they have different starting point. So that's maybe the difficulty for them to start to look at research.
I really can't comment on that because I have very little contact with the private universities. In the UK, there's only 1 or 2 private universities. They're all funded one way or another by the government and by external funding. So I don't know the difference. Sorry.
One thing that's important about what Marcelo said, Norman in his lecture mentioned that he went over the insects to watch them grow into butterflies. And so kids have interest in science. You just have to look at it, and it's your job. You're going to become teachers, professors, you're going to be with students, so it's your job to make them feel interested about the subject. I'm very proud to see that when my students come to me and say, I love periodontology because of you. I say, oh, thank you. Thanks a lot. And I already have some specialists here that we formed over these 16 years of university. So it's your job to make students feel interested in starting research and in scientific initiation. You have to follow professors like Bruna, that works day and night with the students and stimulate them, and so many others that are here with us in the post-graduation program as well. So I think we have nice students and we have nice professors as well. And we are always learning with each other, so that's the important thing. They teach us and we teach them, right?
I've suddenly had an idea. Why don't you have open days? Open days? No. But all the universities in the UK have open days in which the parents and the family are invited to the laboratories to see exactly what is going on. And there's nothing nicer than having some microscopes lined up and they take a sample from the inside of the cells and look under there and people see. Or to show some plates, some nutrient plates, petri dishes, with bacteria and fungi growing in, because the concept of that of COVID, for example, or bacterial infections, if I go like that and put that on a nutrient agar, I'm going to get colonies growing up. But people don't realise exactly what that is. I mean, my wife doesn't realise that. I've always said I'm going to take some petri dishes home with nutrient things. I'm going to show her where the contamination is. You know, I'm always spraying things with alcohol, keep them clean. And I'm actually going to show her sometime. And so having some open days, show some of the projects, show some of the things that people are doing here, is a wonderful way of letting the public know what is going on, and also for stimulating the younger members of the family. You can start in a small way and gradually build up.
We have the project Open Doors UFF, and mostly it's in October in the National Scientific Week. It goes around all over the country, and we have the campus open for schools and for children from the city, and different activities like looking at microscopes and looking at microbes and things like that. And we have the science truck. That's a project from the head of the Institute, Professor Vinicius. He takes the science truck, I'll show you later, it's out there. It's a truck, and he takes it to the schools and plazas and teach the students some things about science, about cell biology. It's very nice.
I'll tell you the one thing that happens when the parents come along and they see a microscope, they put their hand down underneath the microscope and try and see. They see nothing, of course. But that's one of the common things that they do, put their hand on the microscope to see it.
Anyone? Want to ask? Yeah.
Eu gostaria de perguntar, nessa área, mais voltando para pesquisa posterior, você acharia mais pertinente? A gente vai dar os diplomas de mestrados, por exemplo, para a Europa, para lá, ou nesse tempo que a gente estudaria para validar nossos diplomas e tudo mais, fazer uns cursos para aumentar nosso currículo e tudo mais?
Não entendi você. Se você acha válido fazer a validação lá?
Isso. Porque, por exemplo, a gente vai fazer validação de diploma do mestrado lá fora.
Que você fez aqui no Brasil, você quer validar fora.
Isso, só que leva um tempo. Aí a pergunta para você é mais pertinente, fazer isso para fazer pesquisas ou tentar fazer outros cursos pertinentes a essa área para aumentar o currículo, para chamar a atenção.
If you finish your post-graduation, your master degree here in Brazil, and you want to go abroad, and you make the revalidation process in the other country you want to, is that necessary to make a revalidation to go to a PhD? Or because...
They would want to look at your papers and check that they are valid, yes, obviously, before you went into the new laboratory. They need to check you out. Is that what they're asking? Is that what you're asking? If you go to another laboratory...
If it's valuable to make the revalidation of the master certificate, or if you can make other courses to enhance your CV and to apply for PhD or things like that.
Oh yes, okay. If you have your MSc and you have your MSc certificate, or MA, that's valid, okay? But obviously, the laboratory abroad will want to see that, will want copies of that. I mean, recently I had to show my PhD certificate, which I eventually found. So that's valid, but what you're saying is true. If you get your MSc, you get your first degree, or your MA, and you actually go and work somewhere while you're applying for abroad, that will be a good point in your favour, because you're getting additional experience. And additional experience is worth gold. It's really a wonderful thing to do. Especially, I mean, not digging up the roads or selling a supermarket, but something to do with your science and showing that you are interested and serious about developing your scientific career. Does that help?
One thing we talked about was that I asked you, what is the most difficult thing you think about Norman has over 35 PhD students graduated. So I thought, what's the most difficult about supervising PhDs?
I'm trying to think. It's variable with each student. Some students go away straight away and read the literature. Some students keep a nice lab book with all their experimental details in, and some don't. I've had two students fighting in the lab before now, two PhD students fighting. A boyfriend and girlfriend, and they were fighting.
At each other or fighting?
They were fighting each other. I found out about it later, they wouldn't tell me, I would have gone mad. I've had a PhD student who had epileptic fits. We had to get rid of her, unfortunately, because you can't have an epileptic person in a laboratory. And as far as the work is concerned, you have to be prepared to work very, very hard, because you're in competition with a large number of people. But if you're obsessed with something and really interested, you work hard anyway. And the other thing is that I've had women PhD students crying because we've been trying to write papers which were very difficult. And I always ask for the student to write the first draft. But it's important that when they start writing, you encourage them and you show them how things should be done. I remember with my PhD supervisor, I had one afternoon with him, I'd written something, and we laughed the whole afternoon, looking at what I'd written. I never had any instruction after that. The only talent I've ever had is to be able to write something. I've never had any musical talent or dancing. I can't dance, I'm not coordinated. I can't play a musical instrument. I wish I could play the piano, I can't. So it's variable. But the most difficult thing is actually writing the thesis. That's really, really difficult. Writing the thesis itself. Again, the blank piece of paper, you know? It's the same as writing a paper, but it's your first experience, you know? Writing your MSc or your PhD. So, other difficulties. I've had one student who used to go, instead of working in the lab, he used to go walking and buying ice cream. So we had to get, you know, some people are not motivated. we had to get rid of it. Other difficulties that you think?
You talked about lab training, about the processes of the laboratory, and every time a new student comes back.
Yeah, I was very lucky. I had a technician who knew all the techniques that were used in my laboratory, and he was able to teach all the students the same things that I taught other students. So that wasn't difficult for me because I was helped. I had the best technician in the department for some reason. He was also an expert on fungi. He loved birds. He was really more talented than I was. He could go in the woods and identify mushrooms and eat them. I couldn't do that. He knew all the birds in Britain. You know, he used to go. He was a Twitter. That's what they call Twitter. People that study birds. So that wasn't difficult for me. But some of the students were very difficult. Some of the students from abroad were very difficult because if you told them something, then sometimes they got very upset, and you have to be honest with them, you know. They bring in the results, and you look at the table, and you could look down it and see that there were mistakes in it. So you send them away, and they come back. I had an Iranian student particularly who found it very difficult. But we had a good relationship. Thanks to my technician as well, who took the brunt of the problem, because I had a student came to me. This is his story. I had a student from Canada coming to work with me for a PhD. He was from Kenya originally, but he had an MSc degree. He came, he wanted to do a PhD. Or was he a postdoc? He came in as a postdoc. That's right, he came as a postdoc. And I said to I had a team at the time, a group of just a dozen people. And I said, well, you've got to watch yourselves now. I've got this high-flying postdoc coming from Canada. And he's going to work very hard, and he's going to show all you people up and not pull in their way. So the guy turned up. On the first day, he knocked on my door. I was talking to my technician. He came in. And he said, well, what can I said, go away and make me some 70% alcohol. And he looked at me and he said, 70% alcohol, 70% alcohol, and what's the other 30%? Yeah. She said that. I thought, didn't know that 70% alcohol was 70% alcohol, 30% water. That's his starting point. But you know, he worked hard, he learned, and he went back to Kenya and he became boss of the department, and he did very well. Unfortunately, he died recently, but that's another story.
One thing that's important is that once the years go by and you study more and your learning curve is going up, people will demand more of you. So we have one demand for undergraduates, we have another demand for master students, we have another demand for PhD. So we think that if you go into a PhD, you have some independence, you have like you need supervision, but you need your advisor to be there with you, but you become more and more independent. And as you said, a postdoc student, what did you expect? That he would do pretty much the work and need little supervision, supervision.
Something like that.
One thing I have a regret. I have many regrets, but this is a particular regret about being an academic, being a scientist. And that is that I wish, as I am today, I was when I was first starting. Because one thing you have to realise is that all academics are under stress. They're under stress because they have deadlines for marking examinations, reading papers, refereeing, doing administration, teaching.
They have bills to pay, they have to study and work.
Yeah. So they are all under stress. So if an academic seems to be rather short with you, in other words, haven't got enough time with you, and I was always too short with my students. I wish I had spent more time with them. I never used to address them by their Christian names, and they'd always call me Dr. Ratcliffe. But that was fine. That's because I couldn't manage. I was teaching, in the morning I was teaching 3 lectures in different locations about 3 different subjects. In the afternoon I was supervising practicals, then going home and trying to do things around the house, then going out the next day and repeating the same thing, serving on committees, writing exams, writing exam papers. You're supposed to be able to do everything. And the last thing you seem to be having time for is research sometimes. And it's very frustrating. So my appeal is try and be patient with your academic if they don't seem to be quite as nice as they should be sometimes.
The first thing is that we were talking about revision of papers and how important it is not to take things personally. Because if you say, Alessandra, your papers suck, Norman just said that one reviser wrote in his paper, shit. That's very rude. But we must not take a bad revision personally. People are not saying anything about myself. It's about the thing I did and I can improve that. So that's an important tip, isn't it? Don't take things personally. People are not, or I don't know if maybe we should think about the way we are leading things.
Well, that person wrote SHIT, I don't keep saying it. There was a personal thing in that because I'd been to her lab and I presented a project I wanted to do, and she went away and I think she did the project. I've had that happen to me before, whereby I make a presentation at an international meeting, and then 3 months later I receive a grant application to referee, and 1/3 of it was my presentation. So don't take things personally. I didn't haul her over the coals, or I didn't punish her in any way, but I was very upset. And the thing that upset me particularly is the fact that she was telling other people I'd done that to her. So it was a double-edged thing. It was really bad.
This case particularly was bad, but most of the time people are saying, you actually made a mistake, so you should improve yourself. It's not something that discourages you to move.
No, don't be discouraged.
Yeah,
you can get very depressed if your experiment doesn't work or something goes wrong. I mean, I came to Brazil once on one of my visits, and I had an EU grant with Fiocruz and with Germany, and I got equipment. And the equipment was a plate counter. It was for reading automatically results of antibacterial assays. And the plate reader had been duplicated in Germany, and that had arrived in Germany. When I came to Brazil, I was there for 12 weeks, and the plate reader was stuck in the customs. And I never got around to using it. It did arrive eventually. I mean, there was a time, it was wonderful when I come to Brazil, and I had a grant, and I actually brought an osmometer with me. I packed my bag all with all sorts of consumables, and consumables are chemicals and things like that, and equipment, and osmometers for reading the osmolality of solution. It's a piece of equipment anyway. Straight through customs, no problem either. When I came to Brazil, they were ready for me, and fortunately one of my colleagues from Fiocruz was able to explain to the customs that I was a scientist and I wasn't a smoker. But it used to be so easy to exchange things. The terrorism that took place, and everything changed. Everything's changed. Everything is much more difficult now.
So import products and equipment.
Yeah.
That's fine.
Anyone? What? Yeah.
De manhã ele fez várias considerações sobre as dificuldades de pesquisa atual, as revistas que acabam ganhando muito mais do que o pesquisador em si, e agora você mencionou que tem mais de 35 alunos de doutorado, então tem uma longa caminhada de experiência. E eu queria fazer uma pergunta que não tanto relacionada à pesquisa, mas sim à trajetória profissional. O que durante essa trajetória ele faria diferente? Se ele faria alguma coisa diferente, e o que ele faria diferente? E se ele faria tudo de novo?
She wants to know that, do your background, of so many papers and so many students supervised. If you would change anything in your trajectory, or you do anything different, I asked you that already, but would you do anything, or any advice for young Norman?
Yeah, I would have gone to a lecture like this and paid attention. I mean, how many are going to go away now and read? How many have been influenced by that? I mean, really, the important thing is you attend lectures all the time, okay? And I can still remember one lecture from when I was younger. I was doing my first degree by a biology master, and it was a wonderful lecture. I just wonder if you're going to remember some of the points we made here, because nobody else is going to tell you. Maybe your supervisor might, but nobody else is going to come here and sit with you and tell you this. And I hope it's some help to you. What will young Norman do? Try to be a film star.
Become richer, for sure.
Become richer. Yeah, that's right.
It's a nice plan. You mentioned about Facebook, and I said, over 2,000 friends online. And that's some advice I always give the students. Stop looking so much at social media. Stop comparing yourselves with others. And stop wasting 1 to 2 hours a day looking at stupid things. I say this to my kids. Stop making stupid people famous. There are people saying a lot of bad things on Instagram or Facebook. And when you say, I don't have time to exercise, I don't have time to study, I don't have time to sleep, that you must check your schedule and see if you're wasting precious time with things that are not important. So if you have 30 minutes a day to study, 30 minutes a day you should study. Oh, I don't have time to study other language, or to play the piano, or to learn something different from dentistry or from biology. It's up to you to make your schedule. And when we are women, Norman said that, well, there are a lot of girls here, a lot of women. Yeah, dentistry, mainly we have 80% of students that are women. And we have to deal with kids, with our house, with our partners, and with our pets, and with our jobs. And why, when we go to congresses, we have men in dental congresses most of the time? Have you ever thought about that? Why do you think that happens? Because women are dealing with 2 jobs, house job and our jobs outside, and that's it.
I do health jobs. I cut the grass. We've got a 50-foot lawn. I cut the grass most of the time. I clean the floor. What else do you get me to do? I do cooking. I wash the dishes. I make bread. I make bread as well. One thing I always try and do every day, look back on the day and realise I've done one thing that's important. So today I can look back on this day and say, oh, I've lectured to you. Tomorrow maybe we may be less demanding, but try and do something that you at the end of the day you can look back on it, because be proud of it, or you've accomplished something. It doesn't matter how small it is. Maybe you've mowed the lawn, or it doesn't have to be work, mowed the lawn, or you've read some particular paper you wanted to read. I spent some time each day looking at Yahoo News. Now, Yahoo News is full of rubbish, okay? Full of rubbish, but it has some wonderful things in it as well. It has politics, it has health advice, it has everything about films and things. But that's my only social outlet that I have. I don't do Facebook. I don't answer the phone very much because I keep getting rubbish calls. So try and achieve one thing a day, which you can look back and say, I did that today. Otherwise life goes so quickly. I was like you a few days ago, now look at me.
Time goes by really fast, really fast. People ask me before tell me about your experience meeting the royal family. He met Prince Charles, King Charles now, and the Dutch of, I don't know what.
Duke of Edinburgh.
Duke of Edinburgh. So tell us about that.
I have a picture of that, but it's... Yeah, I didn't show it enough, did I? Yeah. One of my memorable experiences is meeting the Duke of Edinburgh. That's the Queen Elizabeth's husband, the Queen that died last year. That's her husband, the Duke of Edinburgh. They were married for 70 years or something like that. He was an amazing guy, and I had funding from a charity. And every year they had a meeting with the head of the charity, happened to be the Duke of Edinburgh. And the charity was for children and babies, and in our case it was for hopefully producing a new antibiotic. And we were using maggots. Have you heard of maggot therapy? Maggots. Now, maggots are the larvae of muscids. Muscid larvae. Those horrible things when you see a dead body and there's all the maggots. Or if you watch the... Well, when something dies, these insects, flies lay their eggs, and these horrible larvae appear everywhere. They eat up the body, okay? They're called maggots. Maggots, larvae, muscid larvae. And they produce secretions. And those secretions contain antibiotics. And we were working on that. And we got funding from this charity, Action Medical Research. And the president of Action Medical Research was the Duke of Edinburgh, the Queen's husband. So the more interesting projects were identified by Action Medical Research, and we had an invitation to go to London, to Clarence House. The Clarence House is where King Charles and his wife used to live. It's one of the royal palaces. It's an amazing place. And there are only 6 of us presenting our work. We had pictures of our work, displays of our work, and he came round and he talked to everybody. And he talked to me for about 10 minutes, which was amazing because normally he shakes their hands and goes. And he was talking, I had a pot of maggots in my pocket, a sterile plastic container with these maggots, and they were all whirling around. And they were producing secretions. And I poured it out and showed him. He was very interested, And he said, one of the things he said to me, I remember, he said, and he used to speak like this, he said, have you tried bats? Have you tried bats? Do you know what bats are?
Yeah.
They live in the caves. Now that's a pretty clever, because the insects with the highest well-developed immune systems are the ones that live in the most disgusting places. That's why cockroaches, baratas, live in sewage, and that's why dead bodies have these maggots. And bats live in caves filled with their droppings. So that was a pretty intelligent comment. But that's how I met the Duke of Edinburgh, and I always remember that. And Prince Charles, as it was, came round. He was Prince of Wales. Prince Charles was called the Prince of Wales, the Prince of Page the Gardens. And he visited the biology department, the zoology department in Swansea. And there were 20 of us lined up in the laboratory. And he came along and said a few apt words and shook our hands and disappeared. And that was the first time I met him. And I met him subsequently when I got my first degree. I got my BSc, he was handing up the scrolls for the BSc. But the real memorable one was with the Duke of Edinburgh in Clarence House, in one of the royal houses. And I opened the door in one of the rooms, and the throne of England was there. And I was very tempted to go and sit on it.
Would be arrested.
I'd be King Arthur then. But that was a wonderful experience. I have regrets about that, but I won't.
We're almost finishing here. Anyone has questions? Well, if anyone has some extra questions, we can then send them to Professor Norman. And no. Okay. So, yeah, we're going to save Norman's presentation for our next meeting. I would like to thank a lot people that are watching online, you that come here, especially Professor Norman for having the courtesy to come to Nova Friburgo to accept our invitation. I have to thank Professor Fernanda Calazans, our coordinator, who made all the efforts to make this possible, Vice Coordinator Bruna Lavinas, who made it possible as well, and our students, our amazing students, represented by Emmanuel. Thank you a lot. This would not be possible without you. And the second most important person here today is William. So thank you a lot, William, for making it happen. This is when we talked about teamwork. None of this would have been possible without a lot of people working together. So thanks a lot for sharing so much with us. We appreciate it and we admire your experience. You show us that it's possible for us to work with our minds for a long, long time and to use our knowledge to inspire young people, people that are beginning. So thanks a lot, Norman. It's been a lovely day, and we hope you come back soon to talk to us again, okay?
I would just like to say something, if you don't mind. I'd just like to thank Alessandra and Bruna and William, because they've been so kind to me, and my wife and I have been treated like royalty. We're in a lovely hotel, lovely meals have been brought for us, and even the journey here was fantastic. So thank you all very, very much. I've never been treated so well in my life. I now feel like royalty. So you can regard me as King Alpha now.
Maria, my best friend. Maria, would you come here, please? Maria's Bruna's best friend. Maria, best friend.
Anyone wants to talk to me, I'll stay here for a while and have a cup of tea or something.
We have some snacks here. If you want, if you felt shy during the presentation, you can come now and talk to the professor.
How are you doing?
William.
Take a picture.
Selfie. Let's stay here to get the auditorium.
Yes, all the students.
A gente fica aqui, você tira selfie. A gente senta. Senta, Maria. Senta, Maria. Cheers, everybody.
Alessandra.
And now 1, 2, 3.
Tchau, Ira.
Vou lá nos vídeos.